It looks like we are live. Hey everyone, you are probably watching this on video on demand because I don't expect anyone to just jump right in here. My name is Chad, Metalhead Maker on most socials. Tonight I am working on a part of the 3D printed guitar that I am building that is sort of packed with all sorts of high-tech stuff in it. Right now I've got a main board that I have reprinted. Originally, if you haven't been keeping up with the project so far, I had a board that was totally built out and somewhat functional after I fried a few components trying to figure out some of the bugs. And since then I have got this remanufactured again through a PCB manufacturer, and I am taking the time now to rebuild this, to add a couple extra little things on it to make it as stable as possible. So let's take a look and see what we've got today. You'll notice in front of me I have a, this is what's called a, oh my gosh, my brain is, it's late. This is a template basically that goes over top of the PCB, and you can use this to put on all of the solder paste before you actually lay down the components. So then you can just stick this on a piece of or a hot reflow plate just like this, or an oven or something like that, and it will reflow the solder and basically solder everything down. So for those of you that are interested in 3D guitar builds or just guitar builds in general, this isn't going to be a whole lot of that today. We definitely still have a lot of that on the horizon, getting all this stuff wrapped up. But in the meantime, I am just trying to get this electronic stuff taken care of. So there we are. Let me get some stuff situated here and we will get started. Okay. You know how this is. Getting stuff up and running the first time is usually a bit of a headache on live streams. All right, let's get to work. Thank you for your patience. So what I need to do first is actually give you a decent view of what I'm working on here. And now, what you're seeing is just simply the holes that need to have the solder paste placed on them. And what I'm gonna do is put some solder paste on here. Not like I'm like a total pro at this. I've done it a few times, enough to make a mess of things and sort of learn my way around it, and that's what I'm doing right now. So let me throw some gloves on here. I've got way too many screens trying to figure out how to best keep track of the stream as I go, because I got a lot going on here, but I think that this should be fine. Okay, so trying to figure out a plan of attack. So here, I don't plan on doing anything here, but I've got that taped off here. I want to make sure that I'm not putting any solder on this area. The rest of this, I've got kind of everything laid out on a board that I can use to just pick and place all of the little pieces. And so yeah, this is me nervously trying to figure out where to start. Let's see, let's go right here. I think what I might do is try to start in one solid line in every direction here. A plastic for, oh, okay, Edward, you might have missed it, but how did you install the fret on a plastic fretboard? I would have assumed it would chip unlike wood. Yeah, before I get started, I could show you. Okay, so if you'll see here, and now this is actually the first time anyone has gotten to see close up what these look like, because I haven't really had a chance to do a deep dive on the build so far. So what you're seeing is I basically modeled in a bunch of channels where the frets go down, and then I super glued it. And as long as it's just the right amount of relief on the channel, it goes in and it stays in. It's not going anywhere. Now, if for some reason I had done that and didn't really, give it enough relief or something like that, it actually causes the whole fretboard to want to sort of bow a little bit. And that can cause some serious problems. So I had to go through 2 or 3 different iterations of this to make it work. But the current version is great. And as a matter of fact, I'll give you a little sneak peek of another fretboard that I'm currently working on. This is a much more, I guess you'd call it like a basic fretboard. There isn't any electronics in it or anything. And that's a good view of the actual relief that I have in there. So it's probably almost 1 millimeter for each one of those slots. And I really have to make sure that those come out super clean when I print it, to make sure that, when the fret goes in, it's not getting caught on anything, or it doesn't, when you push the fret down, it doesn't have any obstructions. So hopefully that answers your question. All right. Blah. Okay, let's just go this way. Let's do this in regions. That's what we'll do. It's probably not enough, so we'll have to probably put a little here. There's no rhyme or reason. I'm just trying to get some coverage here, and then once I come back through, I can really press it in. Like I said, I am no professional here. I've just done it enough to screw up a little bit and figure out some of the gotchas. So basically, I'm just trying to get some coverage first before I really press it in. I was really thinking that was going to go further, but apparently not. I'm going to have to use a lot. I do think that I could have used a little more viscous solder paste. This stuff is not what I would consider prime for what I'm doing here, but that's all right. Just trying to get everything covered first. That'll work. Moving on. So really just getting the solder paste down quickly enough before it starts to dry and become hard to work with is the deal here. Once you get it actually on the PCB, you can spend a little more time because, placing the components, that won't be such a big deal. But just getting it on there quickly before it dries is kind of important, because from my understanding, it is water-based, the paste that the solder fibers sit in, and that can really become hard to work with the longer it sits. Okay, this is much less clean than I would have hoped. see, the last time I did this, it was with a really small board. And it was not hard at all to get one big glob and just kind of work that glob throughout the whole thing. But this is definitely being a little more resistant. So again, you know, I've got everything taped off on the underside that I don't want to have pasted. And who knows, this might fall flat on its face, but never know if I don't try. All right, I think that's probably enough. Can already feel that it's wanting to kind of firm up a little bit, which is kind of silly. So the best way to approach this, if for some reason you're watching this for an educational reason, God knows why, what you'll want to do is get that on there first, and it doesn't have to be super pretty. Then you're going to want to really press it in at a good angle and get the solder onto the board underneath this. That, you know, basically it's going to connect with all those little contacts, and then after that you can kind of scoop the solder off. And of course I don't even have a place to put that, which is genius of me, but I have to come up with something. Okay, so let's press this in really good. And I'm looking to make sure that I'm seeing solder completely filling all of the holes. Without overdoing it. And I just feeling, I can kind of feel when the solder is completely filled, and I can also feel if it feels like I'm tearing it out a little bit. So it's not like you're going completely blind. I'm kind of doing pass 2 and 3 at the same time as I'm pushing it in and pulling it. That's just because of how big the board is. All right, once I get this off here, we'll do a little inspection and make sure all of the little areas here look good. And matter of fact, I can probably even zoom in, and that would help me as well. See if we can get a little clearer. Oh, come on, I know you could do it. Oh, you're gonna fight me. Okay, there we go. I think it's about as good as we're gonna get on camera. That's all right. All right, I'm just gonna put this in here for now so I can not let this totally dry out, because this stuff can be totally reused. That will have to do. As a matter of fact, don't you love live? You get to watch me do all the stuff that gets cut out in the final YouTube videos that I usually post. Funny enough, I watch a robotics engineer for, I think it's Acert Robotics. That guy, he will spend 8 to 10 hours sometimes. Well, maybe that's pushing a little bit, maybe 6 to 8 hours just cranking away at designs and building stuff on live stream. And that is something that is really cool to watch, but it's also something that I wouldn't expect to be trying to strive for right now. I'm just happy to be able to get all my cameras up and running. Okay. I need to just do one more little inspection to make sure that I'm not missing solder from anywhere. I am seeing a couple spots. I might just touch that up by hand. No, wait, nope, actually those are fine, because those right there are blocked off. Never mind, those look good. Just looking through. Now the scary part is going to be pulling this, because the way that you get this up off of the board without pulling all the solder with it, apparently is to just lift it directly up, and if there's any angle or if it's too dry or anything like that, then it can kind of make a mess of things quick. So I think what I'm going to do is just make sure everything is completely freed, get all this tape up off here. We'll zoom back out. And then you'll get to see the mess underneath. Okay. I think it's free. Okay. Wish me luck, guys. Here we go. Well, if I can get my fingers underneath this. See, I know what's going to happen. I'm going to get stuck on a piece of tape or something and it's going to wreck it. I don't see any other corners that are attached. Let's do this. Okay, very good. Okay, here we go. And oh, I felt a little bit of movement, but no, that looks really good. Definitely, I see some spots on the really small components, or the ones that have really small pins, that I'm a little concerned about. But I mean, overall, it still looks kind of solid. Let's take a closer look here. So the reason why I've got all those boards up around it is because that helps me level it. So when the when the stencil that goes over top of it goes on top, it doesn't bow or anything. Come on, sorry guys. You'd think that this, I'm using a decent camera, you'd think it'd know how to autofocus. Come on, behave. Thank you. Okay. So let's get the rest of this tape and then I'll show you. See if we can do this at an angle so you can kind of see what the solder paste did. Oh my gosh, come on. There we go. Okay, you can see that there's just a glob of solder on all those little contacts is what I was going for. It looks good. Tell you what, let's look at this. So me being an overachiever, I had to make sure that I had a little mobile way to show you guys what this would look like in case I needed to go mobile here. So check this out. Let's go this way. Nope, this way. Sorry. Okay, so looking at it from an angle, you can kind of see the 3D dimension of that paste right there. That right there is concerning because there's definitely too much paste on those teeny tiny little pins, but everything else looks good. Very happy with it. Okay, so I think that from there, I'm going to start placing components. So this would be cool. I spent the time, and I did not do this in, just like right before this live stream. This took me all weekend basically to prep for. I got to get faster at it. But you'll see here. So basically this is all the components that need to be on the board. And I'm stumbling on my words here because I'm trying to adjust things as I talk, and I cannot chew bubble gum and walk at the same time. Okay, so basically in no particular order, this is everything from resistors, temperature sensors, ICs or integrated chips, everything you need to make that board work, I hope. And all that stuff is going to go up on that version that we just added a bunch of solder to. And that's what we're going to do now. Cool thing is that I've spent many hours many hours soldering and manually, placing components iteratively. And this is just a really fun process because once you get all the components on, you just drop it on that heat plate and it flows beautifully. Now I need to make sure that I do not wreck the solder on this, obviously. And I don't even know if my board holder is wide enough. I think it is. Good Lord, I hope this does not fall. This does not really feel that steady. Okay, yeah, no, you know what? Let's get you a little further away from that. Just to make sure it's stable. So the reason why I'm doing this is because I'm old and it's really hard to do this leaning way down to the desk for many hours at a time. And yes, it is, even though this adds a little bit of risk, it is much better than the alternative. I don't know. What do you think, guys? Ooh. I know what I'll do. I'm gonna go lock this down. I bought this PCB holder looking at it online, and it said it was metal construction, and that was cool. I thought that was all metal construction. Come to find out, all of this is plastic. This might even be plastic, actually. I haven't really looked closely, but I think this is some kind of heat resistant plastic, and this is metal. So I was a little disappointed. Even these are plastic. I just really hope that this will hold. I'm gonna put a little bit of tape on it to make sure that the, where'd you go? To make sure that the edges of this don't slip off. Also, this green tape is like my new friend. It's just masking tape, but I found a pack on Amazon for like $15 for a bunch of rolls, and that was super cool. This does not feel sturdy at all. Oh, it's only 76 degrees in here too, and rising. All these lights, I may end up having to kill some of my colored lights, because obviously once I get started here, I'm not going to be able to just stop. Okay. Pardon the mess, but I think that will probably hold. Yeah, that just gives a little bit of insurance that it's not going to start to slip. Cool. I like it. Get rid of these gloves. Oh, one thing I should probably mention, just as a side note, if you do happen to get one of these made, these stencils for a board, do what I did and tape the edges, because this is as sharp as any razor that I have. I have almost slice myself wide open on it. Thankfully, I have not yet, but it's going to happen at some point with one of those. So I just took the time and taped the edges and helped a lot. Also, I don't know why they make them so big. It's ridiculous. It's like 700 millimeters by, I don't know, 500 or something. It's nutty. Okay. That's bigger than that, actually. Kind of think I might want to flip this upside down. Yes. Do we have good focus? Yeah, I think so. Yeah, even though this is going to be a little jarring, I think I'm going to flip this way so I can grab the components and place them. This is the nice thing about having one of these board holders, is that they can turn like this and swivel as needed. And when you're really trying to get nooks and crannies that you wouldn't be able to get otherwise, it's nice to be able to turn that. Okay, so I've made this as dummy proof as possible. As you probably can kind of tell, there are a lot of labels on the board, and those labels usually on PCBs tell you know what number of a component it is, or something like R1 or D1 or something like that for a diode or a resistor or whatever. Instead, I don't care if it's messy. Looking on the board, I need to be able to just place components without having to look at some kind of data sheet that I created. So instead, I've opted to just basically put labels on everything. And it's ridiculous. It takes ages to place all that, but it's worth it. Okay, so I think I'm going to do the big things last and start to take away at some of these resistors, capacitors, and diodes. I'll start with resistors. The other thing is that I have, on a test version of this board, I have tested the, just making sure that the microcontroller, which is the Teensy 4.1, goes on here and behaves nicely with the control board header, and that worked just fine. What I would really like to do is iteratively place components and then test and stuff. I did that last time, and that was helpful for understanding where the bugs were, but since I don't have any more bugs that I'm aware of, I'm just a little concerned that I'm going to spend a lot of time pushing or putting parts on, testing, and then, you know, goofing something up, having to add or move the solder around or whatever. It's just a lot easier now that I know that it's probably working okay to just put it all on and then just try to minimize the potential of damage by not plugging the microcontroller in and just testing everything with power as best as possible before actually making anything function. I'm just talking a lot here. I should be placing parts. Otherwise, I'm going to be here literally all night. Let's do this. 470R. Where are you? It's going to be tricky to find a couple of these one-offs. Over here? Yes, there you are. Okay, I already can tell you that I need to get a process because my hands are shaky and I need to basically anchor my arm. Oh, this is ridiculous. Stay. Okay. So far, I've had a lot of success with just trying to anchor in some way, so having my pinky on something will help usually. I got a ton of these little 1Ks, so let me see if I can knock some of these out. I say that and I don't see any of them. Okay, there's one. Okay, I am the one that's sitting here doing this. Anyone that is actually patient enough to sit through all of this, you are a saint, and you are also maybe just as crazy as I am, because man, this is tedious. 1K. I thought about doing some of this on Twitch. Did not. I goofed around with that with some of my music stuff, but I just did not find a community there. It felt like I was just, I mean, that's just kind of how it is, but it felt like I was just shouting to avoid anytime I tried to stream anything. It's just, to me, not worth the stress that you put yourself under to not even have your stuff out on a platform that's widely used by the general population. So I decided to opt for YouTube live stream instead, and so far it seems to be okay. It's a little easier to speak to an audience that is already there. You know what? I think that this goes here. I'm gonna double check. I'm gonna go ahead and place this, but I'm gonna double check before I lock anything in, because obviously having that many labels, it makes it a little hard to fit everything, and I have to sort of line it up based on what space I have. But the reason why or how I'm deciding this is I can look at the label here and figure out where the end of this lines up, or where the end of this one lines up, and logically figure that's how I labeled everything, or how I laid out the labels. 2M2. I know this guy's up here. I've been working on this, in case you're wondering, for well over a year now. So if you're looking at this thinking, what is this and how do you build something like this? You don't build something like this overnight. You spend a lot of time mulling over it and then building iterations of it. I've got multiple versions that I've built. I'm not seeing the other 2M2, but I know that it's here. Man, you guys are gonna probably find it before I did. This guy right here. Here he is. Come on, there we go. Okay, 100K. I see you. Oh no, I dropped it. I knew it was gonna happen. Oh, see, that's scary, because if I dropped it with the rest of them. Okay, I think it's, you know, I don't know. All right, well, that's fine. I'll just get another one. I haven't shown this on my channel yet, but I have, the way that I've done all of my organization for my components is I build these little boxes, and these boxes have my resistors in them, and that is an excellent way to keep organized, because before I had them all in a bundle and I had to basically hunt for every one that I had, and I'm not good at organization usually, so I just bit the bullet and did it, and man, it makes all the difference. Okay, I'm sure I'll find that resistor when I figure out that it got mixed in with another one somewhere and something blows up. Okay, oh wait, which one? I'm getting turned around here now. 100K. There you go. He has a home now. Oh, what's next? Where's my 220? So what I did so I could make sure that I didn't lose these when I was placing them is that this is basically just tape upside down. So these stick to the tape, and that's a really good way to organize everything before you actually take the time to knock it out. I think I just found that guy that was missing, that I dropped. That is what's the number? 1003. 1003. Yep. So there's the one that I dropped. I'm gonna put that one back in the case. Now that the tariffs for the United States, which I'm from, if you're overseas, now that those have taken over and just made components astronomically more expensive, I'm trying to be a lot more cognizant of, just not dumping spare resistors that I have sitting out or something. I try to make sure that I put them back where they belong, because I cannot afford to just keep dumping parts that are now twice as expensive or more. Let's see. Back to 220. Here he is. Okay, and there's your home. Stay there. 1K. 10K. Got a lot of 10Ks on here. That's a very obviously common resistor for a lot of different purposes. What's a little stressful about this one is on the old version, I had to do a bunch of reroutes on a couple big components just to make sure that I wasn't going to burn anything out, and just some bugs that I found. And this one, I supposedly had fixed all of those. Man, where's these 10Ks? I know they're everywhere. But we'll see. Soldering in everything all at once doesn't really leave a whole lot of room for error, which is why I try to make sure that I don't stop, or I don't, drop the microcontroller in before I make sure that I'm not like running a positive to a negative or something. The other big thing is that there's a mixture of 5 volt and 3.3 volt on this board. We don't, and 12 volt, and we definitely don't want that to get mixed up, because I have burned 3 teensies, maybe 4 now, by doing that. Where the heck are these 10Ks that I thought were everywhere? Well, I guess we'll come back to those. I know they're there. All right. I am not looking forward to these right here. These, let me pull this up. These are the motor drivers. Oh, you guys cannot even see half this. My fault. Let me pull this out a little bit. There we go. Okay, so these guys right here, these are the motor drivers for the tuners, and I had a hell of a time getting those placed the last time, and I burnt out 2 of the 3. So yeah, I'm not excited about dropping those in, but at some point I'm gonna have to. I saw a 1K over here somewhere. There's one. Okay. Oh wait, that's 10K. Don't want that. Let's go back over this 1K. I think I saw one more. I think. Oh yeah, I see it. And I lost it. I swear I just saw it. Okay, maybe not. Let's start with, or let's move on to some capacitors. Capacitors are a good way to level the signal, and all these little brown guys right here that I'm putting in. The reason we put that on is because you don't want the signal to just be constantly spiking freely with the power source. Whenever a power source, is not completely stable, it might ripple in some way, and putting these on here allows it to store up just enough power along the path of the signal to sort of allow it to stabilize and not, just be so subjected to that ripple. That's why we're dropping these in, and they're everywhere. 1 UF. So back to what I was saying earlier before I get distracted. I've been building this for over a year. It started out with just a simple little, one of those prototyping PCBs. As a matter of fact, I've got it, I think, right here. You can see it. And once I felt really comfortable, this guy right here, once I felt really comfortable that it was going to work, then I started designing this. And I designed this and got it manufactured through a company called JLC PCB. Now, what is it going to do? It is going to run LEDs. It's going to run motors that will hopefully allow me to tune the guitar or have it self-tune. It's going to allow me to read the signal of the guitar, which will allow me to do a couple things. One, react to that and use it for the tuner, but also possibly read it and do some kind of signal processing at some point, which is not a current version goal, but once I get everything stable, eventually, hopefully. So I think I've got most of the 1 UF, so I'm going to move on to the 100 NF, nanofarad. These are just different sizes of capacitors to handle different levels of, get on there, or different amounts of current. And how you choose it, usually, I mean, yes, you can calculate it and spend all that time, but usually if you just look at the data sheet of the component that you got the capacitor there for, usually it'll give you a suggestion on what to use. It's not like I was able to do all the calculations for every single one of these components and figured out every one of them. I did make sure that I did my homework, but I pretty much just relied on the schematics and diagrams of, or data sheets, I should say, of all the little components on here. And there aren't too many of these on here, I don't think. Matter of fact, I'm going to start knocking out some of the slightly bigger things. I think that'll make some of the hunting and pecking a little easier. Fuses. I've got many spots for fuses on this because I want to have the ability to fuse the entire thing. And as a matter of fact, on this version, I am implementing that quite a bit. Let's make sure that I'm doing this right. 3.5, I think so, yeah. Wait, no, yes, no, wait, maybe. I'm reading these upside down, so let's see, it's 2.5. These are for the motors. I think, I don't remember what that's for. Figure that out in a minute. This one is definitely for the main power. So if you're interested in the guitar side of things and you're you're familiar with active pickups, you'll know that active pickups are usually run by a 9-volt. Well, I have discovered, oops, oh, I flipped that one upside down, yikes. I've discovered that you can run that at a higher voltage. Thing is that the battery packs that I want to be able to run are at 12 volts-ish, and I want to run them, I want to be able to basically pump in 12 volts into this board and then distribute that out to get 5 volts and 3.3 volts and everything. But at the same time, if possible, there's a caveat there. I might not be able to do that after I do a lot of testing and find out that there's just too much interference. But I've got it set up to where I can run the pickup off of this board as well, so I won't have to have a 9-volt. That would be cool if that actually ends up working out. I've got it all wired up. I made sure that it does work fine, but because of the digital signals, oh my gosh, I need to focus. Because of all the digital signals, there is absolutely a chance that I get this all plugged in and I just cannot get rid of that, EMI or that noise from all those signals, and I have to separate out the power rails completely just so I can have a clean signal. Okay, so the fuses for the motors are in. Thing is, I never even got to test the motors because I spent so much time on this board right here just making sure all the other components was working and trying to not fry the microcontroller. Also pointing out, here's a good example of all of the little things that I had to fix, the little bugs that I had to fix. That was frustrating. Here, I've got the same thing. So I'm hoping that with my new reroutes, these are taken care of. In theory, it all makes sense when you're putting it together. And even when you're fixing the bugs, it all makes sense. But until you actually plug it all in, it's hard to say whether or not you've got it right. You just kind of have to go over and over and over it enough times to feel confident and then just hit place order. So what I'm dropping in right now is this is the power management IC or the power management chip, and this allows me to bring in any voltage and convert that, or based off of a basically a pin that allows me to tell it what voltage to pull. It will respond with that. So if I have something called a power delivery, which is, you've probably seen this, the big bricks that that you plug into a wall for a phone charger or something like that, but it can also charge like a laptop using USB-C. That's called power delivery. And this allows me to take a signal from those power delivery and use this to tell it to give me 12 volts. And then I can distribute that out. So that's that. Funny thing with these are diodes. They're called Schottky diodes, and they're really efficient diodes. And I want to say that they are definitely the way to go on this project. I had a weird situation on the last version of this where when I put those on there, I was getting backfed voltage, and that did not make sense to me. So I don't know what the deal is there, but I'm hoping that problem is just resolved with enough fixing that I did, or rewiring. Whoops, that's upside down. What I'm dropping right now, excuse me, this is, oh my gosh, it's escaping me at the moment. You know what? I'm just going to shut my mouth on that one and come back to it, because for some reason my brain is getting a little numb, as is my throat here talking so much. Okay. But since the name is escaping me right now. Oh, transistor, duh. Good Lord, Chad. Okay, so transistors, this is basically going to allow me to take a reference and supply out a proper amount of power using that reference. Basically, allows me to connect the one side to a digital pin on the microcontroller and then use that to tell it to give me the right voltage or the right amount of current from the actual power source. It's a sort of a way to cheat so you don't have to rely on the the actual pin from the microcontroller for the power source. You just control it with the pin, and then the power comes from the main rail or the main power body that's on the board. That's the theory, at least. Do I have 3? Thought I had 3. Oh, yeah, well, I'll come back to that. This one, I don't even know why I'm putting this on here. I know for a fact that that fan that I've got on here is going to create noise on the and the pickup. So I'm probably going to install that and then just never even use it, because that anytime you have a motor, it's going to create some kind of interference. The thing with these motors here, the actual motors are going to be obviously up by the neck or up in the headstock. So that's going to help a little bit with some of the noise coming from them, assuming that everything is shielded right. But down here, I mean, this is just a fan that's like right there beside all of the action. So I'm not confident in that at all. Okay, this is a oh, what is this? Dang it. What is that called? Oh, yeah, duh. Voltage regulator. So this takes we basically step down. We start with that 12 volts that I mentioned, then we go down to 5, and then we need a little bit of power coming from 3.3 volts. Not a ton, because that's all logic level, meaning, you know, it's voltage that just basically is telling things to do stuff. It's not actually pushing like power to something to run things. But for the most part, I just need a little bit more than what the microcontroller can provide at 3.3 volts. So I'm taking the 5-volt rail and pumping it, and just basically squeezing it down using this right here to 3.3 volts. And then I'm basically using that to combine with the power coming from the microcontroller's 3.3 volt supply to give enough current to be able to run all the 3.3 volt components on here. Most of that is going to be in the control board and a couple little extra tiny components. I have to keep reminding myself that even though I can run all of the LEDs that are going to be on the guitar from a 3.3 volt, I don't have the setup to handle that much power. So I have to run those off of 5 volts, which now that I say that, I actually need to make a modification to the some of the stuff that I've got going on here to later come back and add an extra resistor or two to handle that. So hopefully I remember that. If not, nothing will work. Oh, what are you? H224K. Wait, did I put the wrong guy on there? Oh, I got these guys backwards. That's fine, not a big deal. See, this is why it's a good thing that I didn't lock anything down yet. This guy here is actually, I put it in the power management area. This is actually the amp for the guitar. When you think of a guitar amp, this is sort of that. This is what actually amplifies the signal from the guitar and allows it to be high enough to be read by the microcontroller. It's not like I'm using this to, you know, send out to speakers or anything. This is going to be processing and sending this down into the microcontroller so it can read it as a voltage. Excuse me. Drink. Do I put this on yet or no? You know what? No. I'm going to hold off on that. Oh, I found my other fuse. That's right. Let's see. You know what? I'm not happy with that. So this right here is a fuse to I'm gonna put my foot in my mouth. Nope, that's what it is. This is basically what stands in between the 5 volts in the power section and the 5 volts on the actual board. So if this fuse is not in there, I can do all the power stuff and then not have any power to the board. So I can make sure that all the power stuff's working without actually risking any of the other components here. But in doing so, at the same time, I want to, you know, make sure that if I'm pushing too much power, or if I'm pulling too much current, I should say, that I have a way to kill that power later on. Let's say for some reason the motors are just all pulling at the same time and it's pulling like 6 amps of current. We don't want that to just, you know, burn out all the components. So this 1 amp that I have on here, I don't know why I decided that. That doesn't make sense. I'm going to swap that out for a much bigger guy here. Let's do, considering this is going to be running all of the LEDs and everything, it's going to be a fair amount. Let's do 3.5. What is that? It's R. I don't know why these fuses are labeled as they are. It's terrible. They just have a letter corresponding to a value. And I have no idea which, where it is. That's all right though. Well, I just saw it. P, I'm looking for R. R. Yeah, 3.5 amps should be sufficient, because once you figure in the LEDs and running everything on the board and stuff, if I'm pushing more than 3.5 amps at once, I mean, yes, it's not a lot if you're talking all of the motors, but come on, I mean, that's a lot of power running through something that really isn't built for high-powered components. So yes, oh no. So even though oh man, that made a big fat mess. Even though I do spend a lot of time working out components, what I should be using, pros and cons of the different measurements, sometimes you gotta wing it. Things like fuses, I could totally calculate that, but in practice is always a little different than in theory. I'm holding this here thinking I might actually want to not connect this right now. So I'm going to put this here, take this 1 amp back, put it back, and put that away. And I am going to update this. Oh my gosh, I'm writing upside down. Slow progress, guys. Oh, and then I left these out. This is definitely not for the meek. If you are impatient, I would not advise doing stuff like this. This is definitely something that you do with just assuming that you're going to be spending a lot of time and you've got a lot of time available. I've been actually trying to prep for this the entire weekend, knowing that once I got started, it was going to be quite a while until I actually got to take a break or was able to walk away from it. I mean, with all this stuff, you don't really want to walk away knowing that, you know, you got dust settling and everything on the solder paste. Just kind of have to barrel through it. Okay, anyway, back to the power rail. I am going to now install the CH224K chip to manage the power from the power delivery system. I do not like how much overlap there is on these. Almost makes me want to slice them out real quick. So what I'm seeing is that even though I was moderately careful when I lifted the board, there was some overlap and some smudging. Ugh. So I think it's probably best if I just do a little bit of a slice in between each one of these pins. Give it the best chance possible to not gum up together. So basically what ends up happening is that when you reflow, most of the solder just kind of finds its home on top of the pads. But if you've got too much solder, or if things are just a little bit too far out of alignment, it might glop together and you got pins touching. You can usually see it. It's not like it's that hard to fix, but it's much easier to fix before you actually start reflowing. These guys right here, I might actually have to get my what are they called? Glasses out. And I don't mean reading glasses, I mean magnifying glass out so I can really get in there and slice up those pins. I'm still on the fence whether I'm actually going to keep this though. I got these magnifying glass headset thingies and they look silly as hell, so love this. But I don't know, do they really work? I mean, they definitely magnify, but enough to justify the cost? I don't know. Oh, they look so stupid. Let's see, do they work? Oh my gosh, I have to get like right up on it. See, this is what I'm saying. And now I'm gonna get sick just looking at it. I don't know. That seems kind of silly to me. Try the one that's going to give me the best chance of not having to be like right on top of it. I've got a microscope, and that's really what's best for these kinds of things, but like an idiot, I was thinking that I was going to put it on a boom stand, like my cameras, and I think I threw away the original stand for it, and then I decided I didn't like the boom stand, so I've got this right here, and not really any good way to mount it, so that is not helping me right now. Yeah, maybe. This is so silly. Good Lord. Okay, so I am going to try to just carefully find my stable point and just nick in between each one of these. Holy shit, that worked. That worked actually really well. Of course, I've got like 30 of them to do. And of course, with shaky hands, that's not going to be great. So you don't have to have perfectly stable hands, you just got to be able to anchor yourself. The thing is, you need very little solder on these guys. Anything beyond just a small trace ends up just globbing and creating bubbles or blobs. See, I don't think that I'm gonna have to even get super accurate with how I've got these on here. I just need to reduce the amount quite a bit. Oh my god. Oh, there's so many of them. Ugh, okay. One side of one done, kind of. I got a little ahead of myself after the last one of these that I did, last board that I reflowed, and I thought, you know what? That wasn't so bad. I'm going to see if I can do the same thing and fix the teensies that I had burned out. So I ordered all the components for those teensies, you know, the actual factory spec ICs and chips and things that I thought might have gotten burned out, because you can't really tell. You can trace some of the components, but you really can't say for sure what you burned out on those. I've even got the spec sheet for the data sheet and just couldn't really tell if I fixed it. Anyway, I got really cocky and decided I was going to fix it. Bought all that stuff and long story short, completely flubbed it when I was trying to reflow and put the new ones back on, because they've got like this ball type of solder on the chips, on the bottom of the chips, because they're really tiny, and they either go on perfect or they're totally wrecked when you first do it. And I wrecked it. I don't think I burned out the chip that I bought, but it sure as hell is not in good shape now. So either I try to, you know, clean it up and reapply that solder and do it again, or I just call it done, because I can't do everything all the time. It was a fun little experiment. Oh no. So like I said, what I'm trying to do here is not remove or have the solder exactly perfect on every single pin. I'm just trying to remove the bulk, and even if I pull some off of the actual pins themselves, because of the solder that's around them and some on top of them, it should even out. There's just way too much on here. I would love to know how other people handle these kinds of situations. Because this is something that I have not been very successful at so far. I'd say I'm moderate intermediate when it comes to PCBs, but when it comes to very small pin ICs, I tend to struggle constantly. And you see a lot of people that are doing this, they sort of like trust the process. And even though it looks like it's not going to work in the end, it does. And in my experience, every time I've done that, I've been disappointed to see that it just doesn't work out like that. You know, you got globs everywhere, and no matter, I mean, you can add, what's it called, flux and clean it up and reheat it all you want, but you still end up with arcs on the solder. And that's no bueno. Well, I got one side done. Working on the second. Once I get done with this, I can get back to placing stuff. Kind of, at this point, knocking all the solder off of the pins. Should probably fix that. But in my experience, it's much better to have not enough solder than too much. When you're talking about solder paste and reflowing, it just turns into a big fat mess. Oh my gosh, this one's kind of a mess. Come on. This is rough. I am getting close to the end of this part though. That's cool. I'm excited to actually apply some power to this because with all those bugs fixed, man, I might actually get to play this guitar. You know, it's funny. I would be curious to see how many people that are interested in this stuff are actually interested in electronics versus just like see neat guitars and stuff. No shade towards either, but it's a weird mix of audience that I tend to attract. These things are doing nothing for me. Yep, that's what I thought. They're going back. In case you were ever thinking about getting something like this, like these little magnifying glasses, stuff like this, don't do it. They put so much strain on your eye, you end up trying to look underneath them anyway. Ugh. This isn't the definition of tedious. I don't know what is. Okay, that's all messed up. Thinking I might have some problems with that one. But I can't spend all day on this. So we're just gonna let it go and see what happens. Home stretch, guys. Almost there. I swear. Oh, see, now this one's going really nicely. Go figure. In case you're just strolling in, I am building the main board for a 3D printed guitar that has a whole bunch of high-tech parts on it. This is a fully custom PCB that I had manufactured and is going to run LEDs, some motors, yes, on a guitar, and some other cool things that I want to do in the future, but those are really the two big things right out of the gate. And I am right now getting ready to put all the electronic components on this, or the remaining electronic components. I've been working on this for about an hour and a half now, I think, or something like that. And that looks good. So just these teeny tiny little pins I've had some problems with in the past when I didn't clean them up before putting the chips on, so I am taking the time this time to really try to do it right. Geez, I think I mentioned a little earlier that it's warm in here because of all my studio lights. It's warm enough that I'm seeing the paste start to melt a little bit in spots. That's crazy. And it's not even, it shouldn't be that way. I mean, I live in the Pacific Northwest of the United States, so we don't exactly get blazing hot temperatures here. See, I've got overlap even on these, and that's just plain silly. I must have not kept it sturdy enough when I lifted up the stencil. This is not the funnest part, and I hate to sit here and just do it and bore everyone to death, but damn it, it's got to be done if I want this thing to turn out half decent. I'd much rather take the time. You know what? I mean, I've seen a lot of people just like not give a damn and just slap it on, slather it way too much, not enough, doesn't matter, and it turns out nicely. But this is my baby. I want to make sure that it's done right. I think this should just about do it. Get this chip cleaned up here. Oops. Get back on there. Like, the heat does a lot when you finally put it all together and then just put it on the heat. It takes care of a lot of this solder that's just kind of out of place, but all it takes is one that arcs between the two pins that you don't see to cause a big headache. Whether that be, you know, some kind of arcing underneath the chip that you can't see, or maybe even just, you know, spending a lot of time trying to clean up something that is giving you problems after the fact. So let's just get this taken care of now. I'll borrow a little bit from this guy here because I lost almost all of it on that one pin. Cracks me up that this is my hobby. Like, some people play guitar, some people have all sorts of other fun things that they do, and I sit here and poke away at complicated electronics, things that people do for a job every day. I don't get it. Okay. That chip is cleaned up as it's going to get. Man, I lost all of the solder on that one too. Dang it. I might have to put a little bit more on here. That's a bummer. Not that big a deal though. I'll just add a little bit of fresh right here. I got all messed up. So what happens is once it starts to dry and you start to move it around, it just loses its adhesion to the pad. Since none of this is obviously heated up yet, it's just sitting on top of it, and it starts to just gum up and pull itself away. It's almost like it sort of flakes off. I mean, considering the fact that this is the only side of one chip that I've had to do this for since I used the stencil earlier, it's not too bad. Actually, I think it's pretty solid other than this. Almost done. It's just that last pin there does not want to take the solder. I'm just making it worse. Oh, good Lord. Screw it. I'm just going to chance it. All right, but you can look at it. I mean, just look at it. Everything else looks great. It's just this stupid side of this IC. Just that one little side. It's fine. It's fine. It's fine. Okay, so let's drop some diodes on there. And then after that, I think that I could start to really speed up here, because once we get to the bigger components, they kind of go quick. And then I can fill in any of the missing ones that I haven't thought about yet. You know, I did notice though, I have some optional jumpers and stuff that I have on here that now have paste on them that are probably not going to get filled, and I'm just gonna have to deal with the fact that they're going to be empty. But it's fine, they'll reflow just fine without problem. It's just going to look a little funny. Okay, so I'm putting on the SS34 Schottky diodes right now. Boy, you guys are quiet tonight. Thank you, though, for stopping in and sitting through this with me. Otherwise, I have to do this by myself in quiet, and I go insane. As much as I like this stuff, all the setup is, you know, interesting, and you get to the point where you're like, okay, now it's time to execute. And then I end up just doing my best to avoid what should be the funnest part, just because it just takes so much concentration. And doing this on live stream gives me a chance to just kind of talk through the process and stay mentally engaged with it instead of kind of just, you know, zoning out and listening to YouTube videos or podcasts or something, and then realizing that I wasn't even paying attention and mucked up something. So this is just as much for me as it is for you guys. Thank you for being with me. There. So what these guys do is basically they keep the voltage moving in one direction. Problem is that they slightly reduce the voltage because nothing is without some cost. There is no such thing as free lunch. You get the protection of not getting backfed, I just mucked up something, backfed voltage, but at the cost of losing a little bit of that voltage. And you get enough of these in line, next thing you know, you've got, you know, substantial amount of voltage drop. There are ways to handle that. I've seen. I am not doing that on this board, and I'm hoping that, you know, I can just deal with the voltage drop, but because I've got so many complex components, I do really need to carefully make sure that the voltage is moving in the right direction at all times and nothing is getting backfed, because if, you know, since this thing is running off a pretty a potential large current, that can get a little scary. Ah! No! Oh, cool. Okay. Dropped it right in the pool. I think that's most of them. Oh, I see another one. Come on. Come on. Oh no! Where'd you go? Lost it. There it is. I just can't wait to do the reflow, because this is the funnest thing ever, to set this thing on heat and just watch it do its work. We do all this setup and then we just wait for it to get done. That is neat. Okay. Yeah. Let's do the larger ones. So these larger diodes are for the actual power rail itself. I've got an optional battery in and battery out. Basically, the battery that runs the guitar can get fed, can get charged and supply voltage through the same line. But I've got an optional second battery second battery port, just in case I want to be able to interface with the battery in a different way. Let's say I've got a 9-volt battery and that's rechargeable, and I just want to be able to charge that battery or something like that. That's where this guy right here comes in hand. I probably won't end up using that, so I'm not going to put the diode there. And right now, I think I'm going to put this on. Which one is this? Okay, yeah. Finally, after an hour, I'm getting to put that CH224K power management chip IC on there. Earlier I had it swapped with the guitar amp or the op amp up here, and that would have made a mess of things really quick. Running 12 volts right to an amp would not be good. This guy right here, I keep wanting to put it on, but I think I'm going to hold off till later. This is the relay. This is a pretty expensive relay. It's what's going to turn the guitar on and off programmatically using the microcontroller. So I'm trying to hold off till the very end for those bigger components. They kind of get in the way when you're trying to put all this stuff on. Let's see. We can start putting the big caps on. These capacitors here, electrolytic capacitors, are the guys that can really, you know, store a lot of power to help smooth out, and also kind of you can think of that as sort of a power reservoir. And that's really important for some types of components. 2.2, is that right? No, see, I've got that labeled as 2.2, but these are actually 4.7. Why is that? Oh, I know why. So it's not like you have all components all the time and you just never run out of any or anything like that in a home lab situation. Right now I'm out of 2.2 UF, so you can safely usually replace these with replace capacitors with a similar rated capacitor, and that's not really a big deal. You can't always do that with certain types of components, but with caps, it's fine. Since I don't seem to have any 2.2s on hand, I'm using 4.7s, which is pretty close. Plus, considering that the ones that I'm putting on right now are for the motors for the guitar tuners, there's a good chance that a bigger capacitor is probably going to be better anyway. As a matter of fact, I mean, obviously I looked at the data sheet when I was putting this together, but now I'm thinking about it, I mean, these might not even be remotely big enough. If you're talking about capacitors that can handle the draw that a motor is going to pull, we might end up needing to massively beef those up. Who knows? It's been a while, and make sure that my battery's still doing decent. Yep, we good. Let's see. How about we do a different angle? You guys have been staring at the same angle for way too long. So this is my full studio. Bit messy right now. I've got quite a few projects going on. This is in the way. Obviously, I like to play these. Those are the guitars that the main guitar that I'm working on right now is modeled after. So when I finally get this together, you know, it'll be basically just like those. And considering how many projects that I've got going on right now, I'm thinking about having a separate guitar rack just for my 3D printed guitars. What I haven't shown my channel yet is that I've got another one that I'm actually already building, and it is coming out beautifully. All the little things that I've learned on the first build, I'm being able to apply now to that new one, and it just looks awesome. So I'm excited about that. I just cannot wait to actually get another video out for you guys, because it's been way too long. That's why I've been doing these live streams. It's a little better than, you know, just giving you silence, and you can see what's going on the behind the scenes stuff until I can actually produce a video. What are we doing? Pay attention, Chad. 220. Oh, you go right here. Stop. Come on. Oh my goodness. My my motor skills are starting to dwindle a bit. That's all right. It's all that is just a little bit of sugar. I actually kept a fruit bar here because I knew that it was going to start to get a little shaky here with all this fine work. So this is 10 UF. Oh my gosh, guys. I know that this is probably even tedious to watch, but so frustrating how long this part takes, and then you just sit it on the heat panel and it's just bam, and like 30 seconds it's totally done and it's all soldered in. So bear with me. We'll get there. I do want to make sure that we get all that obviously on the heat plate tonight, because if we don't, then I don't want a bunch of junk settling on the solder. So I'm putting in capacitors right now. I think all of these are related to the amp that's on there that will feed the signal to the microcontroller of the guitar. So the guitar's pickup, you can see kind of right here, that comes in right to this terminal here, and then it feeds into this amp, and these kind of help level everything out into the microcontroller, and then this goes out to the out port of the guitar. I think it's kind of important to always go back to what are we actually building instead of staying so deep in the weeds on the electronics and never, you know, tracing it back to what all these little components actually do. At least for me, that helps keep my sanity. Oh my gosh. Okay, you get on there. Ah. For those of you that have just jumped in, I'm basically just building a robotic guitar. All of this is stuff to run LEDs, run motors, and some future state stuff, hopefully with guitar signal processing and stuff. But this is a fully customized guitar. This is a PCB that oh man, now I went and dropped it. This is a PCB that I designed and had manufactured from a company called JLC PCB, and they did a great job. They've actually sponsored a video before. I'm getting ready to do another sponsored video for them. This is not sponsored here. It's just that they really kick ass, and I'm happy to be working with them. Where's this guy go? Or maybe that was all. Okay, I guess that was... See, I know what's going to be happening here. And someone's watching this probably screaming like, it's right there. But I've been staring at this so long that I'm starting to lose my marbles. All right, I'll put him back for now. All right, this beefy capacitor here is for the initial input of the power. We want to make sure that we have plenty of current management, because we're basically taking a ton of power at 12 volts and then dropping that down from there. And okay, see, this is the problem with these guys though. They're so big that they make it hard to work. Man, I think I'm gonna have some problems with this one right here. That's okay though. If I do, I do. Oh, I see. I need another shot key. But you know what? I might actually leave that one off. So I just saw that I have a diode in the middle that I didn't place, and I'm realizing that it's actually probably important that I don't place that there, and I'll point out why here in a second if I can get these out. Okay, so I could drop this one right here. Let's see, right there. But if I do that, then essentially what I'm doing is connecting the power rail of the microcontroller of 3.3 volt to the rest of the 3.3 volt. And God forbid I have some kind of problem where I've got 5 volt somehow interconnected with the 3.3 volt, or let's say I haven't had a chance to test to make sure that the 3.3 that's coming in from the main power rail is actually doing its job. We might end up pulling too much power from the microcontroller, and I wasn't able to test that because I had that connected. So I think if I leave that disconnected right now, I can make sure all the power is working just fine, and then at the end I can come back around and connect that to get a little bit more current from the microcontroller, just to kind of give it a little help, because these voltage regulators that I'm using, they are good for a few hundred milliamps at most, which is not nearly enough. So not really gonna cut it. Close, but not quite. Once I did have to do the math on the 3.3 volt, just because, I mean, with so many little components, you know, at 20 milliamps per component, it's not a lot, but until it adds up, when you've got 20 of them, suddenly you've got, you know, 400 milliamps that you're using, and you're like, oh, you know, this only runs, I think, like 200 milliamps or something like that. So it needs a little help. Let's do some LEDs. Oh man, I always get these backwards, so I'm going to reference the original one that I've got going on. You can see all these little bugs that I had to fix, like this guy right here. I've got a line running this 5 volt to here, which is running to the temperature controller. All sorts of funny little things that I had to account for. That I, for some reason, I think I just designed it wrong. But when you've got that many components, that is not at all a surprise. Okay, so just based off of this, and again, you know, when you've got this many components and you're putting everything together, you don't want to spend a ton of time trying to figure out the orientation and everything. So I'm gonna base it off of this, and I've got green facing left. So why that is, it's because technically LEDs are diodes. That means that power flows one direction. And there is an arrow indicator-ish. Oh, whoa, pay attention, Chad. Is that the right color? Yeah. There is an arrow indicator helping you make sure that you've got the right orientation, but man, when you're dealing with like a complex circuit, sometimes things don't point the way that you would think intuitively until you really look at the circuit and figure out why. So in my experience, it's always best to just make sure you've got that well mapped before, so you can just be a moron when it's time to put it together and just follow the pretty colors and the big arrows. Okay. Now I remember why I had all those 1Ks. Because those 1Ks, believe it or not, if you know anything about electronics, or this is something that you do as well, and you just are a sadist and like watching other people suffer along with you. Is it sadist? I don't know. Anyway, I don't like these LEDs to be super bright, and because of that, I use 1K resistors here, and it really pumps down the brightness of these LEDs. And some of them are a little brighter than others, and I could probably tune it a little better. Oh man, too much there. Oh, that's gonna arc. Hold on. But I mean, it doesn't really matter as long as they aren't gonna blow. That's really the important thing. And then I just don't like to have them super bright because I stare at this thing constantly when it's on, and LEDs are really harsh on your eyes. Ah, it's exciting. We're getting close to the end, guys. At least for the reflow part. Oh, get off of there. Now I'm stuck. Yep, that's an indication that it's getting really gunky now. I've clearly dried out, which is totally fine as long as I'm not moving it around. But the moment you start moving around the material, that's when it gets a little tricky. So I've got red for power, in case you're wondering what all these are. There's little boxes in the middle. Those are LEDs that indicate to me what's going on the board. We've got, you know, a battery indicator, whether or not that's plugged in, whether or not we're getting USB, if we've got 5 volt, if we've got 3.3 volt. Those are all red. Whoops, and then I mess up stuff. Let me fix that. Okay, then we've got whether the guitar is on or not, GTR enabled, whether the motors are enabled for the tuners and the fan. I don't really even know if I thought through whether or not I needed that fan indicator on, but I knew it was a motor and I wanted to have an indicator if it was actually getting power or not, just in case I had some kind of problems with the circuit. But I tried to color them appropriate to each one of their uses. So green for motor, green is go ish. For cooling, the fan is blue. Nope, bet you're backwards. I think. Yeah. Oh, don't fall. Rude. Come on. Oh, man. Okay, yeah. All right. Blue, and then white for guitar enabled because I don't know why. Just because. I hate that this one, it's white, but it's got a yellow tint to the LED, and I know it's stupid, but it drives me absolutely insane. All the other ones are uniform, and then this one is yellow, and it's the only white. Explain that to me. Okay. LEDs are allegedly done. Okay, I need to drop in some other resistors. So we've got, and capacitors. So we've got 100 nanofarad. That's interesting. I'm not sure. I've got some ferrite beads spots here available, and I will usually just jump those with solder manually if I don't need them. I try to not put that kind of stuff in to the circuit because it can introduce a lot of unknown. And ferrite beads are something that basically they're used to clean up signals, and they're very controversial. Whether or not they actually do anything is depending on your thought on it. There are some scientific what's the best way to look at this? Some scientific methodologies that you can come to an actual answer on whether or not they're going to do anything for you. But more often than not, they should be avoided until you need them, because you have very little control over something that you don't fully understand, and I don't fully understand them. Oh man, I always get these turned around too. I can't remember if they're polarized. There, I don't think they are. But this, you get on there. Okay. I can't remember what size inductor this is, but this is an inductor. It is part of the voltage regulations. Basically, we have what's called a buck converter, a fully customized buck converter that I built here, and it steps us down from 12 volts to 5 volts, and then up here just down to 3.3. But yeah, the buck converter is pretty complex. Well, it's not really that complex of a circuit, but it's complex relative to, and the number of components relative to the other stuff that I've got going on the board. Because the rest of it is all just supporting components for the specific little, ICs that I have on this. But this is a tried and true, interesting way to step down voltage without generating a lot of heat. Oh man, that guy right there is not sticking. Okay. This is intense, guys. I mean, I'm sure it just looks like I'm just cranking away on this and not putting in a whole lot of effort, but for some reason it wears you down. Still gonna leave that one to last almost. So this one right here. This is called a logic level shifter, and I need that chip basically. The reason why I have this on a board already is because when I originally bought these, I needed the logic level shifter, and I was curious to how it was best implemented, and I thought I could buy the individual ICs, or I could buy them in this form for the same price and get a good schematic, visual schematic that I can hold in my hand of how they actually wired it up. And it's super simple, but knowing, how close the capacitors are to the chip gives just a visual of, best practices. So I've just got to get that chip off of there here in a minute. Obviously, these are through-hole components, and I can't do anything with those yet because we can't do anything until we get all of the reflow stuff on. So all of what's called the SMD components, which are just basically surface mount, or these little teeny tiny guys that don't go through the board. Let me figure out if I've got any other missing resistors or capacitors. Yes, we do. We've got a couple 100 nanofarad capacitors that we got to drop in there. Oh, I see a 2M2. I was looking for that earlier. Where are you? Oh no. Is that the one that went missing? Wait, no, that's not right. No, this is 100. Okay. I mean, my labeling, I am very proud of my labeling, but it can still get confusing just because everything is so tight in there. But, anything like this where I had to put the label out here, I still made sure I put a line to point to it. And I know it might look like all this stuff was somehow pre-manufactured or pre-built for this, for this board. No, I actually mapped out everything on this, including all of the labels. So I actually had to drag everything up there, connect all the points together manually. So we're talking months of work. Why I do it, I don't know. I really don't know why I do this. It's just kind of like anything else in life that doesn't really serve a purpose for your survival. You do it because it's just what you do. Okay, one last check on these these little pins here before I start dropping this down. I'm seeing a teeny tiny bit of gunking here. No, I missed a 1 UF here. So this right here is actually a really important capacitor. This is the capacitor for the power to the microcontroller, and that can be critical to smooth out the power there. I'm really not looking forward to this guy right here. This is sort of my little reference here with all of my components. So this is the basically the IC for the buck converter. This is what does the all the what's the best way to put this? The routing, I guess, for the power. I'm not going to go into detail about how a buck converter works, but short and skinny is that it just basically takes a reference and brings that back and uses that to set the voltage correctly. And most of the time you get, like, if you buy a buck converter that is just, you know, on the open market or whatever, they are adjustable, and that adds a lot of components that you have to manage and maintain. But they also sell the components for those buck converters in a format that just pumps out the exact voltage that you need within reason, regardless of what voltage you give it. So if I'm giving it 12 volts, as long as I have the right IC for that, which is the LM2576T-5 for 5 volt, it will give me 5 volts output. They are clever little devices. Okay, so I hate this though. So basically I need to snip off the end of this, and then this goes on here, and then I have to bend this just right. So basically this is a through hole component, but it's very common to have these on SMD boards just with the pins bent properly. It is not pretty. I don't have a special tool for it, so I'm gonna have to just make do here. As a matter of fact, I'm gonna have to grab a tool. Let's do that. Don't know what I'll need, so we'll get a couple. And this always wrecks my where are you? Actually, yeah, that might work. Yeah, this always wrecks my tools when you have to cut these metal pieces. What's up, man? How's it going? I am doing stupid, crazy stuff this evening. There's a lot of components left to get put on this board, but I am going to be reflowing it pretty soon. And once I do that, it'll look pretty, and we'll actually get to put some power into it and make sure that it works. Hopefully it does. Go back to this. Nope, that's not it. That's the one. Okay. So I need to, without breaking anything, including my tools. What did I do? Okay, I thought I grabbed it. Blech. I did not. This is not as weird as it looks. If you've ever looked at any kind of power, like the circuit board of some kind of power source, a lot of times you'll see components like this that are have like things snipped off and stuff, it's because they're multi-purpose. Some of them, you know, you might want to use this and put it on a big heat sink or something with a screw to help dissipate heat. When you don't have a lot of heat being generated, you can just use the back of this connected to all of this solder paste here. So when that reflows, it sort of acts as a heat shield. Rewind, a heat sink somewhat in itself. Man, this is gonna tear through these. I think I'm going to have to run and get the big guys. Hold on, guys. Be right back. I am running out to the garage to grab some decent sized tools. What I really should have done is just taken components off of the first version of this. That would have made things a lot easier. But I kind of want to keep that one still functional, just in case I need to go reference it. I mean, also, it's neat to see the progression, because I started out like this right here, right? That was the original one with all this chaos on the back that I manually soldered and thought through and had to, you know, reroute half a dozen times, more than that. And then I got to this, which was the semi-professional version that I'm working on, and it had a lot of bugs in it. And now I'm on this one, it's got a lot more refinement. Hopefully this is the last version. I mean, I already noticed that there's two labels on the microcontroller that are flipped that I'm gonna have to fix so I don't forget later on, but that's small. That's not that big of a deal. But now that said, I still have to basically redo everything that I did before, and this is gonna hurt. I know this seems silly that I'm fretting so much about cutting this, but it becomes a projectile. This metal edge of the chip that I have to cut off right here, it's awful. It's so thick that, come on. Well, okay, I'm getting through it. I feel like this is the kind of stuff that YouTube will ban you from because it looks dangerous. I'm taking proper precautions, damn it. Also, you can really easily break the chip. I've done that too. All right, I think that's enough. I should be able to just bend it off now. Not have to deal with it becoming a projectile. Come on, almost there. And it's moving. Yikes. Whoa, and see, that's what I'm saying. Everything's fine until it goes flying in your eye. Cool. Now, part two is that I have to bend the pins into this little neat little Z arrangement or zigzag. Let's see, how did I do it last time? Because I know I did it a little too long last time. So I need to start bending right on those little notches. Come on. Okay, bent that way. I mean, it's not like, it doesn't look like it was done by a machine, but that's all right. Close enough. And then I have to bend it back this way. And this will hopefully, oh man, this is messing up my tweezers. This will hopefully land right at the same level. So what you want is, you want it to line up right there. So you can solder in this, which will reduce heat that goes to ground. And then each one of these obviously go to the pins. Yeah, that's not too bad. Separate these back out. I've done worse, I'll say that. Cool. Yes, so that guy will go right there. I like it. More projectiles. These aren't quite as dangerous, but... And I'm telling you, all this stuff is just perfectly fine until it's not. It's when it's not even about being cocky or anything. It's just when I get in my, or I should say out of focus and I'm thinking about other stuff, things become so routine, is when I end up doing something stupid. And doing something like that, which I did 2 or 3 weeks ago, just knife right through it, just taking off supports on a 3D print. So yes, I'm a little timid right now because of that. Let's do this at least. Cover it up. Oh, these are fine. No problem there. Cool. All right, I think that looks pretty decent. There's a little bit of an arch to it. It's not gonna affect anything, it's just, I like it to look pretty. Ooh. Okay. Moving on. Actually, guys, I think that was the hardest part right there. I mean, yes, all of these are a little tedious, but that was the one that tends to take the most time. Oh man, as I'm doing this, I'm noticing that that is a lot of solder paste for the small amount of metal that's here. I think that that's going to turn into kind of a mess. I don't want it to like be floating around. I'm going to make sure that these are a little better spaced. Come on. Yep. Good, good, good. Very, very good. I'm saying that as in my head I'm critiquing how bad it is because I've got that weird little arch on this. Okay, and now I'm contemplating scraping some of that solder off. So if it's going on like that, yeah, I might just scrape off the edge here because that's just plain too much. There's no two ways about it. This row right here is unnecessary. I can live with that. And on you go. Oh man. I should have put these on in order so I didn't have to worry about them overlapping. Let go. Okay. These bigger ones tend to behave much better when you reflow though, so the solder paste as it heats up, they just kind of fall into place, which is just the coolest thing to watch. I don't know if it's because I'm a total geek or actually other people think that, but I could just watch that stuff all. I say that I do watch that stuff whenever I'm just vegging out on my phone. Most of the time, first thing that comes up is something silly like a reflow video. It's basically ASMR for geeks, nerds, actually. Whew, okay. I think buck converter done. Yep. Oh man, that CH224K is just sad looking with all that solder mess right there. I really hope that doesn't come back to bite me. What I do need to do here in a minute is to reference the old board for all the jumpers that I have, because basically I just need those jumpers help me choose what, if any. Oh man, you know, I'm looking at these, I'm seeing it's totally different. That sucks. So these help me determine if I'm wanting to do, or shoot, I'm saying this and I'm forgetting halfway through. Basically, the power routing, whether I'm using 3.3 volts, 5 volts, stuff like that, that's what a lot of these jumpers are for. But they all have their very own specific use, and I'd have to actually look at the schematic to figure that out. Before I actually lock everything down, I actually might look at the schematic, because I'm forgetting why I've got this row here. I've got all the labels on them, which is great, but why are they there? Forget. Yeah. Right now I'm looking for any missed, you know, I don't know, resistors, capacitors or something. I'm gonna take a wild guess that someone that does this every day would just laugh and say I would have had that done in 10 minutes. But this is just what I do for fun, so that doesn't matter to me. I don't really see anything that I'm missing outside of that row that I need to figure out there. You guys see anything? I think we're good. We got that row I got to figure out. Not putting that on. Not putting that on. That guy's got to go on still. Oh yeah, he's not going on yet. That right there. I'm pausing on this because it's a really clean solder job right here. There's the solder paste. Like there's very little connection between all the little pins, which is kind of unusual for me. But it's definitely too thick. So I'm probably gonna have to take just a moment and clean that up real quick before we slap that one on and then put these on, and then I guess reflow. But that is such a nerve-wracking thing. It's so fun, but it's terrifying at the same time. Because basically, all the work that you've done when you start the process gets put to the test when you start the reflow. It either kind of just all falls into place or kind of just all falls apart. Just depends. I see all these videos of these master engineers that they just basically slather stuff on and it just works the first time, and I'm like, is that really how it goes? Because that's not how I've experienced it. I don't know. Yeah, this one was really clean as far as it going down, but it's too thick. And that makes me wonder, is there a better way to do this? Should I be, maybe for these really tiny chips, not be doing, not do them at the same time as the other reflow parts? Because everything else, I've got a mixture. I use a lot of 0805 is what it's called, the size that I like to use for resistors and those other small components. I don't like to go much smaller than that. I've got some 06 whatevers, and those things are so hard to work with. So, you know, they require a certain tolerance and a certain amount of solder paste to work effectively. And then you got these like that are right along beside it, and they all get the same amount of paste because it's all the same thickness going on. And this is just way too much. So how do, in a pro environment, I just want to know how they do this. How they prevent these from getting too much while at the same time giving these enough. I don't know. And the reason why I'm doing this and the reason why I have so many concerns about this is because in my experience, when you reflow all this together that first time, it just turns into a big gloppy mess if you've got too much on there. So, or if you drop the IC on top of this and you smoosh it all around too much. Of course, if you're adding flux, that can kind of help things fall in place, but you can't really do that when you've got a fresh board, because obviously the solder paste has to have a clean surface to work with. Okay, I guess now's as good a time as any. So I'm gonna put these on first. These, man, ugh, I don't wanna put these motor ICs on. So I know that probably anyone watching right now was not here for earlier. I kind of went through this. On the last board, I burned out 3 of these. Burned out 2 of them that are on there right now. I think are actively burned out, and that's because the pins are so small that the solder paste just kind of just wanted to glop together and didn't really find its home properly. And it's not actually that I burned those out, it's just that in trying to work the pins back into their proper spots, the pins, you know, I had to kind of move the pins around a little bit because the solder paste was just too thick, and it ended up breaking some of the pins, and so they're dead. And I'm terrified of doing that again, because even though there's are not like the most expensive things in the world, I mean, you add all this stuff up and it starts to get really expensive, especially with the US tariffs now. Shouldn't even be using that word because I'm gonna get dinged or something by YouTube, but definitely makes me nervous that I'm gonna have to buy them again. I should probably point out that the reason why, how I know which direction these ICs go is there's a little dot on this side and a dot on this one, and that tells me. So I just line up the dots on the board to the dot on the chip. And that's a pretty standard process. Matter of fact, I mean, a lot of electronic engineering stuff is built off of very common sense type concepts, and that makes it easy to learn right out the gate. Now, obviously, things get more complex the deeper you get in, but I mean, I'm a dummy and I learned it. They're on there. I've seen guys just like put those things on, they're all crooked and stuff, and they all find their home properly. I've not experienced that same wonder. It has always been a challenge for me. I'm taking this guy off here because this is the one that I did not clean up, and those should have better separation between these pins. But this is just a quick second. Yay. Okay, yeah, that wasn't bad. Again, this is the op amp. Whoa. The op amp is what's going to take the signal from the guitar and pump it into the microcontroller so that it can read it for various things that it needs to do. Funny thing that I've been wrestling with is if I just wanted to have a guitar that had some LEDs on it, in theory, I could have a few components, transistors, things like that, and a power source and a button, and that's it. And aside from tuning, it's not lost on me that technically this is, you know, very largely just an LED guitar, a guitar with LEDs on it, and all these components just serve that purpose. So that's a little hard for me to wrestle with right now. That's why I'm interested in getting to the next phase where I'm able to do signal processing and stuff. But I mean, just getting it stable with LEDs is hard because LEDs have so much potential for EMI or electromagnetic interference because they have to use a digital signal to tell them what color, the brightness, all that kind of stuff. And that can, you know, if you're wanting to have any kind of programmability, you have to use a microcontroller, which does not like guitar signals, or rather, I should say, a guitar signal does not like the LEDs and digital signals and stuff. It tends to freak out, as you can see on some of my other videos on my channel. But getting distracted here because I just put the last big part on. That is the relay that turns the guitar on and off programmatically. I'm going to do one quick check over to make sure that I didn't miss any components. And then, yeah, I think it's time to put some heat to it. I do have to do one thing first. Oh, that's right. I need to, before I finalize, I have to take this guy right here, get that chip off of there because it's got the logic level shifter chip that I need to put on here. But let's look through and make sure we didn't miss anything. And look at these guys. That's right. So didn't need it right now. Nope, we're good, good. All good there. That's good. Okay, we got the right values there. You're a little crooked. Ugh. Must have bumped that. Oh, see, okay, so this is a little concerning. These are the little things that you don't really think about when you're designing the footprint of it, you know, in the schematic design. But I'm seeing now that I think that might not fit with the pins. So I'm going to drop this pin in here just to see. I might have to trim one a little tight, but it does fit. So no, I think we're okay there. Okay, good, because that would have been a disaster. The reason why I say that is because if I pull this off, it's a 680, which is a pretty big capacitor for the board this size. But that the footprint that I had, which was sourced, I think, from JLC, it's like their version. The actual capacitor that I have clearly is not the exact same capacitor that footprint was made for. So that means that most likely I have the wrong footprint and I need to update the schematic just for my own sanity, because I'd hate to forget about that if I need to get it generated again and then turn around and, you know, end up with the same problem. So I think what I need to do is pull up the schematic again. Okay, let's see, how are we gonna do this? Nope, that's not it. Still working out some of my, let's just do screen only. Still working out some of my streaming setups here. Probably do this. Well, trying to not dox myself in the process. I guess I'll start a new browser session. There we go. You didn't see that, whatever it was. No, not the control panel, the board. So basically, I've got two computers. I've got the computer that I work at on, you know, my electronics lab here, and then I got my main computer over there at my main desk, and that runs all of my streaming, which means that all of my stuff has to be pulled up over there. Okay, stop rambling, Chad. Okay, this is the schematic. I need to figure out what these guys go to right here. There's a lot going on there. So this isn't going to tell me much. I need to actually look at the schematic itself, not the layout. Basically, I've just got this broken up into groups, which allows me, makes it easier to kind of figure out what's going on. And I do remember when I had to reroute all this stuff or reorganize it all, I try to make it in a way that allowed me to just kind of dump things very quickly onto the board, not remembering why exactly, though, that they're set up this way. So what do we got here? We've got, it's a jumper, but what is it jumping and why? Basically, you're going to use a jumper in a situation where you may want to do something other than what you originally planned. So you put jumpers in place to you know, take into account stuff like that if you're not really sure how it's going to play out. Or you want to be able to use it for different things. So I need to find my power. Okay, here we go. Here we go. This is what I was looking for. Oh, I know what that is. All those jumpers are there to set the output voltage. So basically, power delivery allows you to set the voltage. Rewind. You can use power delivery, which is just, you know, the USB-C through a power delivery source, like one of those big bricks, and take that power, and it's going to give you any voltage that gets requested, and you can use these jumpers to pull those pins on the IC, the CH224K, up or down, so positive or negative, in a certain configuration to get a different voltage. So according to this, if this is right, I mean, there's definitely a possibility that it's not, just because I don't trust myself. I need to have positive, positive, negative. So that means I've got to figure this out. You know what I'm probably going to do is leave those all empty for now and then manually jump those once I do a little bit of testing, because I'm just not really convinced that I know for a fact what configuration I want. I know that I updated this after some trial and error, but I still don't trust it. And looking back at this right here, all of that mess, oh shit, gotta jump over to, yeah. So looking here, all of that mess right there is because I did not wire it correctly, or I didn't design it correctly, and also because I had to change how things were jumped to get to 12 volts properly. So yeah, I'm probably going to, I guess, just deal with it later. So no jumps there. So continuing, I'm about done. Oh, it's gonna suck. I mean, I know it's late, but losing everyone, and I'm just getting ready to do the reflow. I know, guys, it's late. Oh, I missed a diode there. So the last time I did this, I think I mentioned this early on in the stream, the last time I initially put this together, I was getting back-fed voltage, and I was using Schottky diodes. That was concerning because in the process of doing all of this, like to my understanding, you know, a diode is going to run one direction. A Schottky diode is no different, but in a certain scenario, you might actually end up with power running in another direction depending on how things are routed. And I got myself so turned around that I couldn't figure out if for some reason I was interpreting how Schottky diodes are used wrong, and that maybe I had to turn around and completely rethink how or at least the components that I was using, and I ended up digging out some spare other types of diodes that I have. I can't remember what they're called, but another type of diode that seemed to work, and then coming back to the Schottky diodes, maybe they work now. I don't know. I suspect that I had something going on there. But anyway, yeah, I'm going to stick with the Schottkys for right now. So final check before we reflow. Just want to make sure that I'm not missing anything. See, we got a bunch of little missing parts right here. And these are, I mean, basically just, they're going to be empty, and I might put ferrite beads there to help with some noise reduction, but in my opinion, they don't do that or very well, if at all. So I try to stay away from them, but I still wanted to have the footprint there on the board just in case for some reason, you know, I felt that I needed to do it. Last sanity check is that I want to figure out if there's any of these jumper footprints that I had to put something in that I otherwise wouldn't think to. So I'm looking at this original board, trying to find any kind of little funny thing that I came up with. Oh, you know what? I'll do that later. That's fine. Nope. I mean, this all looks fine. I don't know what's going on there. I think it's good. I think it's time. I think I can fire it up. All right, guys, here we go. Let's see. It's 12:40. I've only been at this for, what, 3 hours now? I don't know. 10, yeah, I'm going on 3 hours. We're going to set this aside because right now I need to get the one IC off of this one board, this little board here, this logic level shifter. I need to grab that off of there. And basically this is just a very, very hot plate, like an oven, or like a stove, I mean. So let's do this. We stare at this desk so long, I'm sure it gets tedious watching. Nope, not that one. Nope, not that one. Way too many cameras. Okay, there we go. Okay. From my wire. I am notorious for forgetting to turn stuff off. So because of that, I am super vigilant about making sure everything is always unplugged, even if it means that I have to hunt around to find it. I would rather that. Now I gotta find the cable. Come on, where'd you go? Spend all this time trying to put together a really nice desk setup, and it ends up just being my downfall because everything's so tightly packed that I can't find cables when I need them. Aha, found it. Okay. I mean, I'm making a much bigger deal out of this than I need to. This is actually not that big of a deal. But it's fun. It's fun to just watch it work so fast. Are we working? Yep. Okay, this will take just a moment. Not very long. We just basically need to get it above 200, maybe like 250 or so, and it'll be fine. See, I've always got all these little boards. Whenever I do this, I get all these little boards left with a bunch of capacitors that my first instinct is, oh, I need to pull those off. I'll use them for something. I'll never use them. I've got plenty of all that stuff, so I just keep these boards and they're just piling up in drawers and stuff, so ends up like this, where I've got like just piles of little miscellaneous things that I need to throw away, but I just can't because I'm a pack rat. While it's happening, I might as well do a little bit of cleanup. Ah! Don't want to bump that too hard. Yes, okay. Almost there. I know. It's like watching paint dry. Yeah, okay. Guess we can go ahead and throw it on. Switch back over here. And drop this guy on. It's very hot, by the way. In case that wasn't obvious. Oh, where did my tweezers go? Okay. So we just have to wait for a second for this to get hot enough, and that IC will come right off. IC, integrated chip. I always say that and forget that not everyone is as much of a dork as I am. Come on. should be just about there. Oh, yep, I'm seeing the capacitor starting to bounce around. You don't want to start to pull up too quick, because if you do, then like a pin or two will start to come undone, the other ones will be stuck, and then next thing you know, you got like a little mess to work through. Ah, now I got parts stuck to my tweezers. There we go. Like nothing. Okay. This guy off here. We'll go ahead and leave it connected since we are getting ready to reflow it again. I think what I'll do is set this here for just a second. Get another board to put this on because it is still really hot. I don't want to burn through my mat. Okay. See if we can widen this shot out at all. Yep, a little bit. Okay. So now I have to get safely, well, let's put that chip on first. And then safely I need to put get that PCB off of the PCB holder and onto the plate without dropping it. Can you imagine if I dropped that? What a nightmare. I say that like it's unlikely, like I haven't done that. I've absolutely done that. Okay. I know I'm off to the side here. I just want to get this one little chip on here and then I can recenter. It's so funny. I always get it perfect on there, and as soon as I'm taking off my tweezers, it all goes to hell. Just having my hand over this thing, it's not burning me, but man, it's hot. Yes, I like it a lot. Looks good. Yes, very good. Yay! Oh, I just thought of something. This is much bigger than my than my heat panel. Oh well. I guess we'll just have to do this in 2 shifts. All right, so I'm going to pull the tape off very carefully, very gingerly. Okay, pull the other tape. Come on, this is about to get really interesting for like 30 seconds. Ah! Okay, tape is free. Oh, geez. Come on. Okay. Oh, see, I just nudged that little diode right there. It's out of place. Not a big deal, but it's so easy to do. And then I will recenter so we can actually see what's going on. Good, good. I had so much problems with the routing for that relay. I have no idea why, but I'm terrified that it's not going to work. Terrified might be a bit of a stretch, but yeah, not super excited about that. All right, so I need to decide, do I want to do the teeny tiny parts first or the big parts? I'm thinking the teeny tiny parts, because basically I think, I gotta not hold this too close to the heat. The teeny tiny parts, I think they're going to be a lot easier to flow and then let be than if I heat up half the board and then have to come back and heat this. I think these things will start to melt and it'll get real messy. That theory could be completely wrong, but I think I'm going to do it anyway. Okay. I'm stalling, in case that wasn't clear. I'm actually looking for a good way to be able to hold and grab this as needed, because that first time I pick it up, I'm bumping stuff again. The first time I pick it up or move it after it flows halfway, it's going to be a little tricky. These are not heat resistant gloves. It's just better than nothing. Okay, there's that. All right, guys. Good Lord. Wish me luck. Also, I don't want to break the board by setting it down and it being too hot on one side but not the other, because that will shatter the fiberglass, but I don't really have a choice. Maybe if I turn it this way and get more components. I guess I'll just do it. Okay. Here we go. Oh, geez. Oh, geez. Oh, shoot. I need to get some ventilation in here. And there it goes. Sorry for the noise. And there it goes. You can start to see all the components kind of ease their way into place. Woo, look at that! Oh, it's so cool. It never gets old. Never gets old. And obviously the parts that are bigger are going to take a little bit longer, especially if they've got big grounds to flow. All right, that one's just about done. I still see that the inductor over here is not done, which is a little concerning. Oh, and some of these, yeah, some of these guys aren't done. I think it needs to be hotter. Hold on. Come on, that inductor is just not going. I might have to use a little bit of heat gun out on that one. Oh my gosh, did you see that? I just like nudged that whole side. Oh, there it goes. I'm gonna have to come back to that side and fix that. See, get a little bit distracted and that's what happens. All right, the inductor's starting to heat up finally. I think it's probably about as good as it's gonna get. Okay, well, I mean, that side's great. That side looks awesome. Whew. Still smoking. All right, you go over here for just a second. I need to fix this mess that I just made. Oh man, that sucks. It's not terrible, but I mean, there's a couple components that got nudged. And they are unfortunately components that, like this guy right here, I think it's gonna make a mess of things. It's nothing the end of the world or anything. It's just Not ideal. Oh yeah, that wasn't a big deal at all. I'm surprised it took as long as it did. I guess there's a big ground plane. This is also 4-layer board, by the way. So, yeah. Okay, so since I have to do the other side, I think I'm going to switch gloves. Let me grab the other one. Okay, I was not planning on going this late, but I'm definitely not. Ah! Where did you come from? It didn't stick. I got one diode that just decided to not stick. I guess that's not that bad. Okay, here we go, part 2. With no one watching. Jeez, okay. Okay, part 2. This is the one that's actually likely to fail in some way. I've got all these little teeny tiny pins. Here we go. Ooh. Okay, so this heat plate, let's see, it's at 220 right now. I really need it to be higher, so I'm gonna set it to 280. That's why it was taking so long before. All right. This is hard because I need to hold this so I don't die of fume inhalation, but at the same time, I need to actually kind of monitor everything that's going on. Okay, well that one's going, oh no, I've got, this guy's out of place. Fixed. Alright, he's fixed, he's good. Kind of. Alright, what the heck, man. My hands need to stop shaking. Oh my gosh. Ugh. No, we're good. We're good. We're good. I don't see any other components that need any more heat, so I think we're done on that side. Guys, I think that's it. I think we're done. Whoa! That would suck! Yeah, see, I see some arcing, but that might be because those are connected pins already. I see one diode there that seems to be... I see one diode that seems to be off right there. I'm going to fix that real quick, but let me get this heat off because that is freaking hot. 280 degrees Celsius. I don't know what that is in Fahrenheit, but it's very hot. Okay, very good, very good. We survived. Now, I don't want to burn my board here. You know what? Let me put this on a silicone pad. Jeez. It's like time is of the essence right now because all the components are on there and everything, but I need to make sure that everything's good before I shut down all the heat for the night. Okay. Good, okay. I know that we had one diode that fell off right here. We can fix that. I don't know why he fell off. He was doing just fine over there. I guess probably not enough solder paste. And then this guy right here is wonky. Other than that, I mean, I just need to probably get a microscope on some of these and get rid of the teeny tiny little solder balls that formed. Everything looks really good. Yeah, it really does. Let me zoom in a little bit. Okay, yep. I mean, it's looking pretty good. Let me fix those couple. Oh, good Lord, it's late. That's okay, though. We're gonna get this done. Now, typically I would use like hot or heat for this, but since there's only two of them, or hot air, I should say, since there's only two components that just need tweaked, then there's no point. I'm just gonna get in here with an iron. Where'd you go? Okay. Is it ideal? No. Do we have enough solder on there even? No. I think I'm about to put some more on there. Not a big deal. That's fine. A glop there and a glop there. Yeah, I don't know why that fell off. Every other component did great. I'm still pissed off about that one right there because that was perfect, and then I nudged it right at the end when everything was heated up. I'm just going to get this one heated up here and reattached, fix a couple tiny things, and then run some power through it to see if I've got anything misrouted. It takes a long time to really debug things if you want to do it safely, and I have burned too many microcontrollers by just plugging in stuff thinking I did it right the first time, and I'm not doing that this time. I have an unspoken pact with myself, I guess now spoken, that I can't keep buying more teensy 4.1s because they are just way too expensive, especially now. I think the last one cost me $42 and I've burned through 4 of them in total. No thank you. This takes a minute because this is the power rail, so you got to heat up not only the diode itself, but the rail that it's attached to get it to really stick. Because obviously it's not like through hole or anything, so you can't just preheat the hole and then as it's hot stick it through or something like that. You gotta either use hot air to heat the whole component, or if you're just doing a little patch like this, just get the ends hot. Man, this thing is just giving me some trouble. It's rocking. I mean, I don't know, is that on? I guess, yeah, it's on. Okay. And then this guy right here for some reason went sideways. I have no idea what happened there. He was doing just fine until he wasn't. I'm actually really impressed with how well this went. I know that this is no longer like my first time doing it, but when I did this the first time, man, I fought tons of these little ICs. And even though I'm pretty sure this is nice and secure, I'm just double checking by heating both sides. I think we're good. Okay, what's left? Let's do this. There's a funny little quirk that I have. Yes, I use that stuff, but I also have a tendency to use paper towel to properly clean it, because for some reason, I know it's 450 degree iron, but I just feel like I can't. I'm blanking on what this is called. I don't know why. It's late. That's why. I just feel like it doesn't quite get it clean enough, especially if you need it to. You need to not have imperfect particles, mincing around with your solder. Okay, so what I need to do is figure out where these globs are and whether or not they're bad on these small ICs. It'd be awesome if I had a I don't want to burn my wires. Stop. Sorry guys. Oh, get over there. I would just rather not start a fire right now. Anyway, it'd be nice if I had a magnifying glass. I might have one. Got a little cheap one. I guess this will do. Okay. I don't know if we're going to be able to see this. You might actually be able to see out of this magnifying glass. That'd be so cool if you can. Gotta clean it. There we go. Good enough. And let's see. Hey, look at that. You can actually see it a little better. Oh, okay. I did not expect that to work so well. Cool. What are we doing though? Yes, pins. We need to look kind of at these pins here because, as you can see, they have, there's little globs. I need to figure out if those globs matter or not. The reason I say that is because some of these pins are purposely doubled. So you'll see here these rails, pull this over a little further. Let me flip this the other way. What do you expect? You're watching a live stream. This is the kind of stuff that happens. It's not edited. Okay. Okay, so these rails right here, these little power traces, they're really thick and they run 2 pins per trace. Ironically, I'm not seeing any arcing on these. I see one right here. It's a little ball. You can see it, the little solder ball. But then over here, basically, I don't mind if that stays there because those are all connected to the same ones. But obviously I can't have them connected if they are for different pins. So I have to figure that out. This right here on this side, I don't know what happened here, but none of these should be connected. So I need to probably heat that up and get these little solder balls off of there. Problem is, you start making a mess of things really quick when you start targeting specific pins. It's not that it can't be done. It's just it's usually not super clean. That's when flux really comes in handy because you can get it to help separate. As far as this one goes, I need to dig out my microscope and be sure because I think I see 2 right there, maybe 3, 4. And then over here, These look great. Oh, nope. There's one right here. Yep. Sometimes you can cold break these. It's not great. You can mechanically break the solder though without heating it up. And if you can do that without any damage at all, sure, why not? That's probably not going to happen though. It's rarely is a totally successful thing. And then I just bent my tweezers. Okay, so that needs fixed. I think this guy here is good. Yeah, that one's fine. So one here, maybe two, I don't know. I'm gonna get out the microscope. And I mentioned this a little earlier, but my my mount for my microscope no longer exists. So it makes this really tough to do this without making a mess of things. Either way. We can do this. We can do it. So what I'm looking for is the connection points. Yeah, see that right there? That's got to go. Oh, this will make me seasick. Those are fine. Really, it's that. That. This looks like there's two on that side. Maybe one right there. One right there. So that was on this one right here. And then I'm going over to here. Trying to stabilize it. Like I said, I don't have the stand anymore, so makes it a little hard. Oof, look at that. Yikes. Yikes. I mean, that is a... It looks super clean up until some certain spots. So the last time I did this, I got into like a shouting match with it. Basically, I had to keep heating them and separating and heating and separating. And even though I used flux, they just didn't want to separate. And call it inexperienced, sure, but it felt like I was just fighting the materials no matter what, even with all the proper techniques that I had learned. One right there. Yeah, so basically all of these I'm going to have to just use a soldering iron to get, you know, kind of cleaned up, which shouldn't be terrible. I need to stop making it sound like it's going to be worse than it is. Let's just do it. Okay, so what I'm going to do is I'm going to put a little bit of flux on there to kind of just help the solder flow in directions. This stuff makes such a mess of things. It's never clean again after you do this. And then I just hope I can wick it up a little bit. Speaking of wick, could try this. Let me just see if I can get it first just by pulling it away a little bit. So I'm contending with the fact that, here, actually, you know what? Let me move some stuff out of the way here. I have a tendency to let my workstation get chaotic, and that's probably the worst thing I can be doing right now with tiny little parts like this. So I'm going to move some stuff out of the way. I'm definitely not going to get all the way to testing the board tonight. I'm 3 hours and 15 minutes into this so far, but I do at least want to get everything on there and make sure that I don't have any improperly arcing pins. Opposite right there. Yep, there it is. I don't know if you can see that on camera. Yes, you can. That right there is the little glob. Seems like it was so easy to do, but you get it stuck in this little, like, it's almost like a loop where you pull some off and then something gets globbed and it pushes itself to the other side, and then next thing you know, you've got, you're fighting it, and it's making more and more of a mess of things. So good. The only way I've found that you can sort of clean off flux is with isopropyl alcohol. That helps a little bit. Oh no, look at that guy. He just fell right off. Oh damn. See, that's a problem. That's a real problem. Come on, get off of there. Okay, so typically I would never be aggressive like that and just kind of nudge it off even though I knew it was soldered on, but I thought that it was not connected. What happened was that little diode that's floating around there, it was, originally it was a little wonky, so I had to retouch it. And when I did that, apparently it wasn't, I didn't get it connected on both sides. That's a shame, because now I have to get another one, and it bent the little pad right there. It didn't break it, so it shouldn't be a problem, but it doesn't take much. I am over here looking for my SS34 diodes. Here we go. Even though that other one's fine and I could probably bend it back in place, it's just the fact that it's bent already. Oh, you're off screen. Just the fact that it's bent already tells me that I don't want to mess with it. Just put a teeny tiny bit of solder on there. Oh man, yeah, that thing is like popped up. Just an ever so small amount. Oh, I said small amount and I globbed it on there. Get this guy on here. Ah, lost my tweezers. There. Man, what a long night. Jeez. I knew this was going to take a bit, but man. I don't like it. As I'm pushing this on here, I can feel that one on the left is raised, and that's no bueno. We'll live with it. Yeah, I'm just not happy with this. I might have to bust out the heat gun, unfortunately. Yes, this is definitely going to heat it enough to make it stick, but look at that. For some reason, it just does not want to hang out. Okay, we're going to do a different route here. We're going to put a lot more paste on, and we are going to use the heat gun. See, this is the stupid thing. Everything goes fine, and you get one doofy component that just wants to give you a hard time. Makes your night bad. an otherwise pretty smooth reflow process. Man, I don't know what happened there. Okay, heat gun. I don't like using this because just basically if I bring the heat gun out, then it has to cool down, and I have to do a whole thing to make it cool down. It's very tight quarters where my soldering iron is. Okay, so and not only that, but man, I'm right beside all these other components. I'm afraid I'm gonna muck those up. I think what I'm gonna do is just really try to target it carefully and away from everything else without blowing it away. I've done that. Yep, there it goes. Yeah! A little bit too much. Okay. Let's hope that that sticks. Am I in? Nope, yeah, that worked out. Yay! Yeah, see, it's still got a little bit of wiggle to it. It's because it bent that pad. Whatever. I mean, it is what it is. If I keep mucking with it, I'm gonna make it worse. So basically, whole board's great. That one little diode there is having some problems, and we're just gonna have to let it have problems. Nope, Chad, stop messing with it. Okay, I'm gonna stop. Moving on. I gotta fix these last few pins that seem to be arcing, and then I mean, you can see it with the naked eye, kind of. Problem is that, oh, see, okay, I need flux. Oh, nope, that's not flux. Woo! That was close. All right, I might have to get in the way of the camera here for a second with my big fat head. See, this is what I had problems with previously. You get these 1 or 2 pins that don't behave. Flux should help. Yay! It worked. Where the solder actually went, I don't know. I don't see it. Usually it's on the tip of the soldering iron, but whatever. It's not there. Now the question is, do we want to bother? I think I'm going to leave those because those can stay connected. Not a big deal. These teeny tiny little solder balls that are scary float around. You don't know why they're there. You don't know where they go. And then they end up casually connecting 2 pins that shouldn't be connected. And then it's too late. It's bothering me. I know I said I wasn't going to touch them, but I'm going to at least try. Nope, those are not separating easily. The reason is because they're actually connected by the trace. The trace is really thick. So we are leaving those. And of course, we will look at this deeply under a microscope before we actually connect any power to anything. Okay. That whole row looks good. I haven't checked the other side, but I'm gonna go ahead and flip over and do this one. There's one right here that needs cleaned up. And that one is really close to the inside. Don't like it. Yes, it does not want to come out of there. And it's so thin that I've had to do this before. I have to get a knife in there. But then you start mucking up the pins. I don't even like holding the soldering iron on the IC for this long. Hey, it worked! Yep, little teeny tiny pieces of solder that have come off right there. I think there's one right here. Just those little micro-sized solder balls can reap havoc. I see that one a little bit better, but it doesn't mean that it's coming out easy. I'm sure this is a very very non-standard way of cleaning up pins, but I've done this enough times to know that once in a while you just get these pins that do not behave, no matter how much flux that you put on them. So I'm just trying to nudge out that extra glop. Yes, excellent. I think we only have a couple left, and yeah, all of this is done. Right there, we got 2 or 3, and then a couple over here. Yes, flux. Look at it. Look at what mess that it's making out of the board, though. I hate that. Alcohol never really makes it totally clean again. I'm having trouble seeing because of all the reflection from all the lighting. Punk. This little solder ball right here that is just, it's bouncing all around everywhere except for where I want it to go. Oh, you little bastard. Yeah, got it. Kind of. Ah, don't go back. Okay, we're good. Kind of. Nope, nope. Come on. Get out of there. I think we're good there. Okay. This is rough. Yeah, I'm getting a little quiet because this is the stuff where if I make a mistake, I have to start over and the IC is wrecked. I do not want to ruin another one of these little baby chips. I don't understand how some guys do this though, the pros. I see them cleaning up these pins. They throw flux on it, throw some heat on it, suddenly it just kind of separates. I've not been my experience. I've always had to do something extra, like nudge it in the right direction or something. what I'm doing here is I'm not putting force on the pins. I'm just basically providing some separation by having the tweezer head in there. So when it finally melts, it doesn't immediately like try to reconnect the pins. Got it. Yeah. Oh God, what a mess. Gross. Okay. Yeah, bear with me here. I know it's going to get a little quiet for a second. But I don't want to screw it up. Hey, look at that. That worked. I think what I've done wrong in the past is I've spent too much time trying to mechanically separate them instead of letting the heat do the work. But I don't know. In my experience, you do have to kind of give it a little bit of help with something like tweezers or a X-Acto knife or something while you're heating it. Otherwise, the pin has a tendency to want to just share its glob with the one next to it. I'm a little worried that there's still a chunk right there. So, you know, this is where it gets scary. Spending so much time with that much heat in one spot, it's just not good on the board. I think that's separated though. Oh, that one came off like nothing. Okay, that's good. Yeah, this is clearly just my inexperience showing on these kinds of boards. I've got enough experience with bigger ICs, but these tiny pins is something I just haven't done a ton of. And I'm sure that it's one of those trust the process kind of things where if you just put your flux on and heat it in the right way, it'll just kind of find its way out of there. But for me, it's not really behaving. For the most part, I mean, it's still coming out. It's just taking a little longer. Yeah, see, that one worked just fine. Last one. For some reason, this one's really bad. Oh, I see why. I think that's ground. Anytime you've got something like ground, it takes a lot longer to heat the pins. Oh, that one came off beautifully though. Two more. Ah, that would work great. Man, the last time I did this, I think I spent a couple hours on these, and then I ended up with broken ICs because I overdid it. I overworked them and broke the pins. For some reason, it's going better this time. Well, I think I'm a little more experienced now. I don't know that I'm doing anything a heck of a lot different. See, I just did that in like a second. I don't know. Probably something has to do with being more confident in the steps that I'm taking to make it happen. And I'm just not just hacking at it like a psychopath. For my own sanity, I think I'm going to try to separate this one over here. So basically, this is one. There's one over here that it's connected to a trace that is really big, and they're both connected to the same one. Ah, it came off just like that. So it's not bad that they are connected, but that glob just looks ugly as hell. Oh my God, did I actually do it? I think that is every one of them. I think I did it. I'm gonna clean this up here, and I'm gonna take a look at it again with the microscope and maybe apply a little bit of power. It is 1:40 in the morning here. I don't know. I'm not a full-time YouTuber, so I have work in the morning, and I probably need to do that at some point time soon. Go to bed. Gross. Oh man, I hate flux more than anything. It is just the worst to clean up. Blech. This is the worst. It's like it's fine until you get into these little nooks and crannies, and I swear it just does not want to come up. This is 99% alcohol, by the way, just in case you're wondering, and you're not sure if you can just spray stuff on a circuit board. I mean, it's not connected, so it's not like it's a big deal if it got water on it or something at this stage, but I wouldn't spray like 50 or something like that. Okay. Maybe do just a little bit more cleanup. And then I'll look at it in the microscope. Cleanup more than anything. I mean, even though, yes, it makes it look tolerable because it's gross when it's got all that gunk on it. Makes it easier to tell if you've got actually an arcing pin or something like that. If you are just joining, basically I'm just building the PCB or the main board for my guitar. This thing has LEDs, it's got motors to tune the guitar, all kinds of stuff. This is all fully custom. I built this, I designed it, and oh, you've got to be kidding me. That thing has been giving me problems all evening. I need to fix that. But yeah, so I'm just in the final stages of putting all these little components on before I actually fire it up and give it a shot. And this one little component, this little diode here that popped off, for some reason it just does not want to stay on. And I don't know what the deal is. I mean, obviously I need more solder on there, but I don't know. Every other component has been just fine except this one. Just need to make sure this is hot enough. Okay. And obviously I don't want to disturb the other components, so I need to be really precise with this. Oh, it's so disheartening, because what happened was it got I bumped it, and then just thought it was fine and bent it. So these little pads here that normally are think, Chad, think. Normally these pads are recessed in the board, but they got pulled out, and it's this one stupid little component. It's not hurting it, but I gotta get it to stay. It keeps getting moved. Oh, dang. Okay, don't fall off. Okay, and then I get to go on to the fun stuff. But I gotta get this thing stuck first. Behave. Behave. There you go. Very good. Now don't fall off again. Good Lord. So weird, man. That sucks, because it's just, you can even tell that it's got a bit of a play to it now. That's going to just be a recurring problem. I'm just going to have to be really careful with that side of the board. I mean, once it's in the guitar, obviously I'm not going to be bouncing it around or anything, but while I'm working on it, still is kind of a mess. Yay! Other than that, things are looking good. I hate flux. Okay. Home stretch. I have a stand for this, or I had a stand for this, and then threw it away. I think I threw it away, thinking that I was going to use a boom arm, and I hated the boom arm. So went to go back and find the stand, and I can only find a part of it. But once I get this thing like kind of stabled down, it doesn't really matter. It doesn't have to have a stand, and obviously in focus. I'm looking for any kind of an unintentional connection between these pins. I'm also fighting the glare from the light here. You know what? I'm going to turn off this light for just a second. Okay. Very good. Okay, now I can see. That may... See, this is the problem with flux. That may look like it's connected, but really I think that's just a glob of flux. Because I've gone through each one of these, and it looks different when there's actually a problem. These look good. Okay, we're gonna move over to the other side. Oh my gosh, nope, wrong way, this way. Really, I wish they all look like that, but this is not my day job. Come on. All right, looking good. So that guy right there looks great. moving on. I hate how smooth this is going in comparison to the first time that I did this on version 1 of the board. Oh my gosh, those look beautiful. Jeez. Okay, that one's a little, that whole side's a little wonky, but I mean, still, overall, there's no connected pins that shouldn't be connected. So that one's good, totally. Moving on. Funny thing is, I bought this microscope thinking that I would use it maybe twice ever. This has become invaluable in this process, because even though you can I've got really good eyes and I've never had to wear glasses or anything, you can kind of make it out. I can even use magnifying glass, but you just really cannot get this level of detail in a way that is relaxed enough that you can really stop and focus for a little bit. With the magnifying glass, you're always trying to move the perspective and in and out just to kind of keep it in focus, but here you can kind of just focus on it for a bit. Yeah, that looks good. So that one's there is good. So all of the really complex, tiny pins look great. Now it's on to the ones that are comparatively much bigger, and these should all be good. Yes, that one looks good. So that one right there, that's the op amp. That's the one that processes the guitar signal and pushes it into the microcontroller. Now we're looking at this one right here. This is the power management IC, or power management chip. This is what helps regulate the voltage coming in from the USB-C PD power delivery. I think those are all good. Yeah, a little earlier I did have to separate 2 of those, I think. So these should be good, but I haven't double checked. Ooh, wait a minute. What are you? Oh, no, that's, oh, you know what? That looks dangerous. I can tell, because this is one that I had to separate, and you can kind of see, let's see if I can get this in here. Come on. Going this way. You can kind of see this little nub right there, and that tells me that I've got to probably just heat that up real quick. Other than that, it looks good, so I'm gonna heat that up and I'll try to keep it somewhat in focus here. Sorry guys, this is hard to hold still. I miss my stand that I had for this. Okay, there. Okay. I'm doing this for me as much as for you guys, because it's nice to be able to see this up close to see if I'm getting rid of that glob. Right at that tip, it feels like that's gonna arc. Yeah, and it is. It's still there. See how it reconnected? I'm glad I checked. Oh, look at that. Sometimes it just works. I was able to pull the connection out. All right. Cool. Hi, where am I from? I am from the Pacific Northwest in the United States, and it is stupid late here. I did not mean to be up this late, but you know how it is. Once you get started on a project, it's hard to stop. Or at least for me it is. Guys, I think that I am to the point now where I can probably put a little bit of power through this. I don't have any of the pins here, but yeah, I think I can. Where are you from? The one thing that I've noticed is that rarely do I get people from the United States that are watching me because of how late I end up streaming. So I end up talking to people from all over the place. Okay. Let's shift up here. Okay, so far, I've got all of the SMD components. Finland, see, there you go. Oh, that is so cool. It's awesome to have you here, man. That's crazy. Anyway, so I've never talked to anyone from Finland. That's just really cool. So I've got basically all the SMD components or the surface mount components here connected. I don't have any of the through hole stuff connected like these, you know, header pins or anything like that. I need to get those on there, but this is enough to be able to run power through it to see if I can get a proper voltage, because really what the end goal of tonight is to make sure that if I connect 12 volts through here, then I can get 5 volts through here, and then maybe I can check to see if I can get the proper 3.3 volts here. And assuming that's the case, then I should have some LEDs that light up, and that'll make it kind of fun. Really, I just want to make sure that I don't blow anything up. That's the big thing. The one thing that I'm concerned about on version 1 of this board is I'm starting to lose everything. Version 1 of the board. I'm gonna use this camera. You can kind of see there, I've got this little ring. I had to, on the voltage, or rather the power management IC, I had to completely rewire that on the board. And I'm hoping that in version 2 here, on this black one, that I did it right. I don't know. I'm still a little uncomfortable with that one. And I did burn out a chip or two by having that wrong. But let's do it. If you're down, then I'm down. Okay, so what I'm going to do is, first of all, switch over to this guy right here, if it's still working. Cool, it is. I'm going to use my my power supply here. It's just a little 10 amp power supply. And I'm going to run bare minimum. I'm probably going to run like 1.5 volts through it and just kind of see where the voltage goes. The idea here is that if I've got anything interconnected that shouldn't be connected, it will tell me, because I'll start to see the amperage jump immediately. And really, when you're looking at this board here, there should be no reason that I've got any real amount of amperage being pulled. The only thing on this board really that should be pulling amperage is the LEDs, and that might be a few milliamps, maybe 100 total if they're full brightness. So yeah, I think what I'll do now is let's switch back over to desk. Oh, by the way, that was my latest addition, was having a handheld camera that I can just grab and point to things. That was that's a game changer when I have something really small or maybe out of frame that typically I wouldn't be able to show. Okay, I'm stalling, clearly, because this stuff makes me nervous. So what I'm doing now is looking for the positive and negative on this, because I was smart and labeled these properly, even these. I think I just forgot to label this one and this one properly. So even though I know my boards pretty well and I can look at the schematic real quick, I need to kind of do a sanity check here. I think it's that right there. Let me just run this to be sure. I'll just do a quick little continuity test. Matter of fact, I probably should do that before I run power through it anyway. So let's find a ground, a known ground. Okay, so I've got all these little test points here. Yep, so that's ground. This right here should be interesting. Yeah, no, that's fine. This should be 12 volts. Oh, 12 volt bus, actually. Yep, okay, so that's good. That's also 12 volt bus. Or not. Yeah, it is. Yep, that's the same thing. And then they get... So basically, these are... What I'm doing is looking at the pins for the power delivery input. I've got a USB-C connector that connects to all these pins right here. That way I can just connect this to a computer to program the Teensy 4.1 that goes right here, or I can connect it to a power delivery station like, I don't know if I can pull it. I know I can't pull it. I've got a power delivery bank here that can give me, you know, something like over 100 watts or something, or way more than that actually. You know what, that's a little bit close. I don't like how those pins are. I might come back and clean that up later, but they're not touching, but they're close. But yeah, so no, I think we're good here. So basically what I need to do is just very quickly, just to make sure that there's nothing that smokes when I connect these pins, or connect these 2 points, positive and negative, 1.5 volts. I just want to make sure that I'm not seeing any voltage spike on the power supply, which I'll pick back up right here. And we are seeing none, which is excellent. That's what I expected. I don't want to see anything happening on the board. I just want to see that we weren't showing any amperage immediately spiking. So we're gonna raise this to, let's do 3 volts, not even up to 3.3, just 3. Reconnect these. Bleh. Okay. And we're not seeing any amperage, which is good, it's expected. So as I get up to about 5 volts, that's when I expect there to be something happening on the board. So we'll just go ahead and crank it to 5. And I realize that there are more scientific ways to test this, but this is, in my opinion, in my experience, a good way to kind of just, you know, do a sanity check, so you're not potentially burning out something before you even had a chance to really do a proper test. I'm going to switch to the other camera now. All right. What I expect to happen is, if I've done everything correctly, now I'm thinking about it, I purposely don't have the 5 volt rail connected, so we may not see anything. Maybe if I'm thinking about this right, we might see USB light connect or light up. That might not even happen until 12 volts, but let's see. Not seeing anything. But let's go ahead and kind of wedge these in here and take a quick read. Okay, so, oh, I just realized you guys can't even really see that because of the reflection. Let's do 12 volt bus. So we should be, oh, I guess it would help if I was actually Checking for voltage. Okay, so 5 volts, good. Yeah, that's expected. So this right here is a good example of parasitic loss from the diode. So you see how I lose like almost a half a volt? Well, I lose a half a volt because of, I believe it's this right here. I think it's this diode. Yeah. So the SS54 causes me to lose that. I can't regain that. I mean, there are ways you can, there are techniques you can use to ramp the voltage back up to the appropriate amount. But I mean, we're talking about like an extra layer of complexity. It's not like it's out of the realm of possibility, but I'm not doing that. Not for something like this, if I can get away with it. Hopefully, I just never have a problem with 4.5 volts, because I think that's as low as it goes. There's no other backflow restrictions that would reduce the voltage in the rest of the board, so I think we're good. Okay, now knowing that, that means that here I should be getting, whoops. Yep. This is kind of falling off. 4.54, we're good. I'm just thinking of anything else I need to test before I connect this right here. So this is the fuse that will allow me to actually get some power. But really, I would expect USB to be lighting up right now. 1.385 volts. That's probably why. It's because it's expecting 12 volts. This will be interesting. I think I'm ramping up on my power supply right now to just really what I need to do is get it up to 12 volts, because this section is asking for 12 volts because of this IC. But I don't know what's going to happen when I do that, so I'm just going to try to keep it as low as possible for testing purposes. Okay, so I mean, I see it's rising, 1.595. Let's just go to 12. But I'd rather not, but I don't see anything smoking right now. I mean, just to clarify, I've got 12 volts running to this. That is an IC that's supposed to help me, well, I should say it's managing the power delivery up to 12 volts. 1.78 volts. For a while? Interesting. Whoa. So why don't we have a light here? I would expect this LED to be lit up. Looking at my reference board here, that is working. You know what? As a matter of fact, I can go as far as to connect this. Yeah, see? Oh, but USB light isn't showing up. Oh, you know, actually, you know what? This is doing exactly what we expected it to do. Why that isn't showing up, I don't remember. There might be a jumper that I disconnected or something. I don't remember. Anyway, that's the working one right now, but that's V1. I'm on V2 right now. So yeah, let's just connect the fuse and see what happens. Oh my God, it's past 2. I have work in the morning. I gotta get to bed, but I'm not gonna. I gotta see this through. Okay, this is a 3.5 amp fuse. You know what? Maybe I'll go with a really small fuse right now, just so if I do happen to run too much power through something, I'm not going to just let it run wild. I'd rather blow a fuse than blow the board. These are my little small parts containers that I 3D printed. Let's see, so according to this, if I just did a 1/2 amp, I need the, oh, it's just called 0.5. They name these things so terribly, the fuses. Most of my stuff is really well organized, but my fuses I haven't got to yet. They're just kind of stuffed in here. 15. It's a scavenger hunt. Come on, Meow. I know, I think they're white. 20 or 2. 30, 12, 20. Come on. You just have such weird naming conventions for these things. Dude, this is not cool. Oh, it's right there, staring at me in the face. Get in there. I get messy with my desk and my work area, but one thing I do not screw around with is small parts. If I'm using a small part, it gets pulled out and then it gets immediately put back where it is unless I'm getting ready to pull it out again. And that is because I have made an absolute disaster mess of small parts in the past. You know those, if you do electronics, the little strips of resistors where they like come in this little pack and there's tape on top and bottom. I just had piles of those at one point and I couldn't handle it anymore. So I ended up just completely organizing everything into its own little teeny tiny bin. And that is how it lives now. I would use heat gun here, but I think that considering I'm just putting this one on, it's probably not necessary. Where'd you go? Be careful, man. I'm gonna connect these 2 wires that shouldn't be connected. Stay over there safely. Nope, this guy. All right, so this is a, what was it, 1/2 amp fuse, 500 milliamp. Come on. Waiting on my soldering iron to heat up. I know it's super interesting. Dude, come on. Well, this is a big old power rail, so it's taking a long time to heat up. There it goes. Side 1. Well, thought it was on. Apparently not. I hate hand soldering SMD components. You just can't really see what's going on because the contact points are usually at the bottom. Well, underneath, I mean. Okay, this is just, I'm gonna have to use heat, a heat gun. Bummer. And a little bit more paste. Here we go. Okay, this goes on and then we get to test again. which is fun. The only thing I do is make sure I don't blow it away. I gotta remember to take this off though and put a proper fuse there, because half an amp is not much when you got this many components. Okay, yep, that's good. Hey guys, guess what? I get to actually make an LED light up, hopefully. Dude, if an LED actually lights up on this, I'm gonna be over the moon. What do you think? What do you think? Is it gonna happen? All right, 3, 2, 1, please. Look at that! First time. And the lights aren't too bright, which is good. And guess what? I also hear the relay running, so that means that the relay's working also, which is awesome. I'm gonna bend these so they can kind of get wedged in there and hold in there temporarily so I can do a little bit of testing. That is a big deal. I'm sure that you guys like, okay, you lit up some LEDs. No, what I did was I pulled power from the input through the IC, which I didn't even connect the jumpers. I got to figure out what kind of voltage it's actually generating. But it's coming in. It's taking that 12 volts, dropping it to 5, and then dumping that out all the way through here into the LEDs and giving me that. So that means the power section and as a bonus, the relay is working great. That is huge for one evening. There we go. Don't arc. Come on. Don't get. Yep. Don't cross the wires. Never cross the streams. Okay, I guess I'm gonna have to just kind of let that balance there. I just want to do a quick little test to see if I'm actually reading 12 volts. Ah, come on, I mean, behave. Let's find a ground. I'm just gonna try to hold this all at once. Why are you crooked? You shouldn't be crooked. Oh my goodness, I've got another diode that is not happy. You should be connected, but you're not. I'm shocked that this thing worked with that diode just loose like that. Whoa, see? I think I just accidentally touched a positive and negative together. No. Oh, I get these backwards. Doesn't matter really, but just for consistency, I will use ground to ground and positive. So I'm just trying to test for 12 volts. Okay, yeah, I mean, I'm getting basically 12 volts, which is exactly what I expected, which, oh, I'll take it. What am I doing? I am trying to make sure that I'm getting 12 volts everywhere I expect. Yeah, I think we're good. I mean, just the fact that the relay is working tells me that not only did I hook up the relay correctly, but I think. I mean, unless that's a bad sign, which, you know, once we plug in the microcontroller, we'll know. But just the fact that we've got power on first try, that's everything right there. So I'm gonna fix that real quick, and then I'm gonna call it a night. Thank you guys for hanging out. This has been hell of a long process here. I started at the beginning of the evening with a completely blank board, and we are here now. Come on. So I'm just going to take this little diode off of here, figure out why it's not holding. This is what I was worried about. I might have actually pulled the... Oh, dude, that's not good. So it has a pad, right? Let me just use this. So this little pad here, it's not healthy. I must have bumped it at some point earlier this evening, and it's kind of bent. It's just not behaving. I think that the pad is still there, it's just bent, but it's possible that, sorry guys. Let's back to the overhead. So it's possible that it's just bent, but it's also possible it could have broken off. I can't really tell because of all the gunk that's on it. I'm just gonna add some more solder paste and we'll see what happens. Oh man, my hands are getting super wiggly right now. Been up for too long. Alright, but the diode still looks good. It doesn't look bent or anything, which I had one earlier that I actually bent. So basically everything went on perfectly, but I've got two of these SS34 Schottky diodes that misbehaved. And I think it's because the pads on them are just on the model in the schematic were just too damn small. And I should have known, because I even when I was designing this, I was like, man, that doesn't look right, but I'll go with it because that's what the manufacturer came up with. It was actually a manufacturer footprint is what it's called. Oh, it was done and then it fell off. That's fine. The solder's on there though. Get the solder hot. Get this on here. Let it sit for just a second. Hopefully that's the end of that. Yeah, it's solid. It's this guy right here. He's loose, and I think I just gotta be really careful with him. Apparently it's a guy. Well, it's been a long road. I think it's time to call it for the night. Guys, thank you so much for sticking around again. I will be probably streaming again to wrap this up. I wasn't really honestly planning on streaming the entire thing, but I just kind of got on a roll and figured, you know, I mean, we made it this far. It seems to be going well, and we'll just kind of keep going until either something starts smoking or it actually works. So maybe tomorrow, we'll see. If so, it'll probably be around the same time, maybe 8 or 9 Pacific time. Until then, if you have any questions, drop them in the comments of this or go check out some of the other videos on my channel. I've got a whole series on building this guitar from scratch before that I did like long before I started live streaming. So thank you again, and I will see you guys soon. Take care. If I can ever stop the stream. All right, guys, peace.